The other day, I spent hours going through supplier invoices and matching them to our delivery dockets. Literally going through hundreds of invoices and noting them down in an Excel spreadsheet and trying to reconcile them with the logistics team's delivery docket tracker. In my mind, it felt like trying to crunch numbers by hand rather than using a calculator. I experimented with the same task using AI and it turned hours of work into minutes. The way we work is fundamentally changing, and the reality is most people are ignoring it. People are still spending their weekends manually typing out progress reports, copying site diaries into cost trackers, and noting down and coding delivery dockets. Not because people want to or they enjoy this, because they don't know there's another way. With the development of large language models and other artificial intelligence tools, we can now build complete schedules, find errors in our estimates, automate progress reporting, and review contracts all in a couple of minutes. And to do this, you don't need to be able to code or have a computer science degree. I have no idea if we're about to see artificial superintelligence and we're all on the verge of losing our jobs, but I do know with the current technology, the current capabilities, we can already do some very impressive things. The people who master these skills and learn how to use these AI tools are going to do more and better work, get promoted faster, earn higher salaries, and manage their businesses more efficiently. My name is Tim, and I've spent the last 10 years working in the construction industry across a range of renewable energy, civil construction, and oil and gas projects. And I've recently left my corporate job to go all in on AI in construction. So this video isn't hype from software bros, it's all about the practical application of artificial intelligence to construction project management. In this video, we're going to be covering what AI actually is and how it's likely to change the construction industry, the fundamentals of large language models, the technology and prompt engineering, automations for repetitive tasks, managing your construction data properly, AI risks and how to avoid them, and then I'm going to finish with giving you a specific roadmap for how you can master these AI skills. My goal is to give you a roadmap for how to learn the skills that will be the new way of working in construction project management. 800 million jobs are expected to be automated by artificial intelligence by 2030. But as we all know, the construction industry is slow to change. Billion-dollar contractors still manually scan in all their invoices, use paper-based checklists, and run everything in Microsoft Excel. There's been software out there for literally decades that would make all these tasks 100 times easier. But the reality is, in the minds of these contractors, these systems work, so why change them? ChatGPT and other large language models are amazing technologies. And seeing how easily they can perform writing tasks that used to be reserved for the most educated in society, it's a natural question to ask what's coming next and how's it going to change the construction industry? Well, I want to start with a disappointing disclaimer. I, nor anybody else, can tell you exactly what's going to happen. We are terrible at predicting the future. In the year 2000, everybody thought that by 2025, we'd have personal robots in every home, flying cars in commercial use, and fully autonomous cities. However, we're stuck still trying to connect our printers to the Wi-Fi network. If there's one consensus between all the top AI experts is nobody knows exactly how the future's going to unfold. So yes, take everything I'm going to say with a grain of salt, but I've spent over a decade working in the construction industry and I'm currently working on an AI-powered construction estimating and contract management software. On top of this, I'm being super careful with this analysis not to base it on technological advancements that haven't yet happened. I'm very much basing it on the current capabilities of these large language models and other AI systems. So here's how I believe AI is going to change the construction industry, and just as importantly, what's not going to change. So in this video, we're going to be covering what actually AI is, where the technology is likely moving, some important realities of the construction sector that are going to shape how it's impacted by AI, where I believe the short to medium term impacts are going to be, and the major roadblocks to an AI-run construction industry. But first up, let's get started by setting the scene let's give you an overview of what actually is artificial intelligence. Put simply, artificial intelligence is just technology that mimics human intelligence. It's got the ability to acquire and apply knowledge to do valuable work. That could be economically valuable, that could be socially valuable. And in essence, what that means is that AI can learn from data, make decisions, and take action. Okay, so AI is more or less a bundled term. It actually means a lot of different things. And now I want to just break it down a little bit and talk about the different types of artificial intelligence or smart machines. So the first form, which strictly isn't AI, but we can think of it as a part of the AI process, is automations or narrow artificial intelligence. These are simple software tools that follow rules or scripts. The classic example being a calculator, where it doesn't think in the way we think, it just follows a set of instructions, often much faster and much better than we can. If you ask a human what 27 times 83 is, it'll take them a while to work it out. If you ask a calculator, it'll give you a correct answer very quickly. Now, narrow artificial intelligence or automations are simply a deterministic process. It's a software script following a set of processes. If we think of this in the context of the construction industry, it might be something like a site diary that automatically populates data into an Excel spreadsheet. So we have a form, we populate the weather, the work that was done that day, what people worked on what tasks, what quantities were complete, and it populates it into a spreadsheet as a record. Now, generative artificial intelligence is the technology that has thrust AI into the limelight recently. It's ChatGPT, large language models, and other tools like that that can generate new content like text, images, or code. These are technologies that, based on what the patterns they've seen in their training data, given a prompt and context, they can format a response to it. So this technology is referred to as a large language model. A large language model is a tool that's been trained on huge amounts of text from books, websites, technical documents, basically all the data in human existence. It learns the pattern, the grammar structures, and the meaning in that data. And when you give it a prompt, it'll predict the next word or image or line of code one step at a time based on what it's learned. Think of it like this. If you type a scope of works includes, the model will then fill in the next blank. So what would normally come after the scope of works includes, it'll then fill in the blank after that. Importantly, large language models, while they seem like they do, they don't actually understand what they're writing. They're mathematical models that predict the next word or token in a change. But this technology is incredibly powerful. So if I use an example from Claude and I've prompted it, can you write an example scope of works for a concrete construction project? It's generated this response from it. It's generated a full scope of work. So Claude is one of these large language models, and based on this prompt I've given it, it's given me the most likely response. So unlike an automation, large language models are probabilistic. That means if I type the same prompt into that same model again, I'll get a different answer. When automations are deterministic, regardless of what you do, they follow a set series of steps. Large language models like ChatGPT or Claude, as you've seen, are always limited to this text interface where we type in a prompt and we receive an answer, which obviously has some massive limitations. The next form of intelligence we're going to talk about are AI agents, which are systems that go beyond just responding to prompts. They can plan a task, use tools, make decisions, and take step-by-step actions towards a goal without being told explicitly what to do. So unlike chatbots, agents act proactively and can handle multi-step workflows. ChatGPT, Claude, if we're using the web browser, we type in a prompt, we get a text-based response, or an image if we ask it to generate an image. An agent is a technology that's built on top of the large language models, but with added capabilities such as goal setting, where you can tell it what to do, not explicitly how to do it. Memory, it can remember tasks across time. Tool access, it gets access to external tools like your email, your calendar, Excel, Google Sheets, so it can fill out information, can send emails, can book appointments. And reasoning loops, where across multi-steps they can break down a task, decide what to do step by step, and then they can determine if things go wrong and check the output of their work. Basically, like, rather than having an AI which is just generating text, you have an AI that has a to-do list and figures out the steps and finds a way to get it done. So let's say your goal is make sure we send out subcontractor RFIs 4 weeks before we need them on site. The AI agent would break this task down and determine it needs to check the schedule, so it would connect to your project schedule, determine when the different subcontractors are starting on site, identify the upcoming work packages, check if RFIs have been sent, if not, draft and send them, track the responses, and notify the project manager if anything's overdue. All we're doing is setting the outcome and the agent handles the process. Again, this technology is built on top of large language models. Now, an important distinction, and where people often confuse the two, and I definitely confuse the two for ages, is you can have an AI workflow, which is an automation, so a set series of steps with a call to a large language model in it, like a prompt, or you can have an AI agent. The difference is a workflow is simply a set of steps that refers to a large language model. It's got fixed logic. So for example, when an RFI is submitted, send it to ChatGPT to summarize and email the project manager the result. That's an AI workflow. An agent is where the large language model, the AI tool, is deciding the steps it goes through, and it can adapt based on what's happened. So for example, you'd set an agent a goal like keep the RFIs under control, checks the RFI logs, sees what's late, sends follows up, updates the dashboard, and flags issues. Agents are where we really get into the realms of using these AI tools as autonomous workers, as opposed to just tools to generate content. Okay, so far we've spoken about intelligence behind the computer screen. The really exciting thing for the construction industry will be when this intelligence interacts with the real world through intelligent machines and robotics. These are machines where AI is integrated into the hardware, allowing machines to perceive the real world, make decisions, and perform physical tasks. For example, a self-driving car that's able to navigate through the city on its own, a robot dog that can walk through a construction site, avoid obstacles, and scan progress and update a progress tracker, or a warehouse robot that picks items off shelves and loads them onto pallets. These systems combine sensors, AI models, and robotics hardware. We're already starting to see a little bit of this on construction sites where they're using drones for site inspections and mapping, robotic survey equipment, autonomous earth moving equipment, and, well, we're not really seeing this yet, but concrete printing robots. So this is where we're taking the AI out of the computer and it's interacting with the real world. So to briefly summarize, artificial intelligence isn't just one thing. It ranges from basic automations, which we've had for years, generative tools like ChatGPT and Claude, to agents where these tools start to perform tasks autonomously, and then eventually to robotics, where this intelligence is used to complete work in the real world. So now we understand what AI is, let's now talk about where the technology is moving. Are we about to see artificial superintelligence and all be out of work in 18 months, or are chatbots and large language models as far as it's going to go? One of the tough things about AI is there's so much fear and hype. There are tech CEOs that are desperately trying to raise money from investors, so they're pumping up the technology as much as possible. And then there's a whole group of people who prompted ChatGPT once, it didn't give them the answer they wanted to, so they've written it off as a complete waste of time. Well, the truth probably lies somewhere in the middle. So now let's explore some of the near-term advancements we're likely to see in AI. These aren't my opinions, these are what the experts in the field are saying. AI is currently like having access to Albert Einstein, but he's locked in your basement and you can only pass him notes and information to get requests. You can ask him, how does an electrical transformer work? And you'll probably get a very good answer. But if you ask him a question like, which electrical transformer is best for my project? He won't be very helpful because he doesn't have the background context. He doesn't know your specific situation. The next evolution of AI isn't necessarily going to be about making Albert Einstein smarter. It's going to be integrating these tools into our work every day. It's about connecting these models with real-world data, tools, and giving them decision-making authority. Here's where the technology is going and what the top researchers and labs are saying. So the first and most obvious trend is simply moving from the text in, text out, chatbot style interactions we're having to integrating these tools into the real world. We're going to see AI integrated into your calendar, your email, your Excel spreadsheets, all the different tools you work. So rather than just simply getting text back from a text input, going to start to see these AI doing real work through automations, integrating them into automations as we discussed about, but also giving them agentic control. And Microsoft's Kevin Scott says the exact same thing. And it's more or less an obvious conclusion to draw that AI is going to get exponentially more useful as it's plugged into more systems, our calendars, our emails, our logs, our sensors, so it can do real work. It's going to get given more context, more decision-making authority, and access to more tools. The big one I see as being incredibly important in the shift forward is as AI gets access to more information, it's got more context, and it will make better decisions. It doesn't actually need to get more intelligent, it simply needs more information. So if I ask ChatGPT, what transformer should I use for my project, but I don't give it any information, I'll get a generic answer. If I ask ChatGPT what transformer should I use for my project, but it's got access to the design drawings, it's got access to the project schedule, it's got access to all our past supplier performance, the vendor quotes, the project location. It's able to analyze this, take this all as context, and give us a very specific and likely useful answer. Okay, so the next trend that's worth discussing is that current advancements in large language models may slow, but labs are exploring new methods to reach artificial general intelligence. Now, I've already said, I don't actually think in terms of how useful AI is going to become, that this is an incredibly important tool. I think when you use tools like Claude and ChatGPT, it's already incredibly intelligent. Sure, sometimes it hallucinates, sometimes it gets things wrong, but it generally gives you very good answers given enough context. So if it's got access to tools, access to enough information, then this generally won't make a massive impact. But everyone's saying that scaling the models, the current large language models we have, with more and more data, more and more computational effort going into training the models, isn't necessarily going to get us to artificial general intelligence. So GPT-4 was powerful, but its improvements over GPT 3.5 were incremental, not exponential. Top people in the field are saying the same thing. Sam Altman, the CEO of OpenAI, has said, we're not just going to get there by making the models bigger, they're going to need new ways, new methods of generating intelligence. Jan LeCun, Meta's chief AI scientist, says the current large language models are not capable of reasoning, they're trained to fill in the blanks, not to plan. So what's next? We're going to see different tools being used to solve problems, increases in memory and context, plan of thought modules such as chain of thought prompting and tree of thoughts, and also multimodal integration such as text, video, audio, and sensor data. The next advancement that we're certain to see, and everyone's been saying it for the last 15 years, is that driverless vehicles and robotics are going to continue to gradually expand. So fully autonomous systems in chaotic environments like construction sites remain extremely challenging, but controlled repetitive environments like mining, warehouses, and precast factories are already starting to use more and more robotics. I think everyone thought driverless cars were going to happen much faster, but as Elon Musk has recently said, when you're interacting these robotics with chaotic real-world environments, there's a huge long tail of edge cases that are harder and harder to train the models to adapt for, which has slowed down the overall adoption. The CEO of Built Robotics has said a very similar thing where they're focused on easy, repeatable, high-risk tasks, not building general-purpose complex robots. They're very focused on trenching and grading repeatable tasks. So what are we likely to see? In construction, we'll probably see robotics first scale as a service through labor hire companies with things like drone scans, rebar tying bots, layout automation, and sites with repeatable processes like solar farms, wind farms, mining projects, without a lot of interactions with the public, you're going to be the first to adopt these. So to summarize, there's really the three trends we're seeing. We're seeing AI is going to start moving from chatbots to interacting with real world tools and templates and being able to do economically valuable work. The linear progression through the large language models is unlikely to continue. It relies on not so much scaling up the current models, but more about speculative technology to get us closer to both artificial general intelligence and superintelligence. But without further huge advancements in these models or these technologies, AI is already capable of doing incredibly useful work. It just needs to get plugged into more technologies, and the path to intelligent machines interacting with the real world is likely to be much slower. Without huge advancements, artificial intelligence can already do some amazing things. But the construction industry has some important realities that are going to shape how AI is adopted. For us to make any sort of meaningful and specific prediction about how AI is going to shape the construction industry, these are the factors we need to consider. The next factor I want to talk about, which is very important in how we allow AI to make decisions and actually give it authority to do things, is that construction is high consequence. Mistakes can cost lives, millions of dollars, or huge amounts of disruption. So unlike software where you can just ship updates, and if there's some issue, maybe your software goes down for a couple of hours while you fix it, construction just isn't like that. You can't do a concrete pour, then decide to change it later without spending tens of thousands of dollars. The risk profile means that new technologies are always treated cautiously, especially when it touches safety, contract critical processes, or spending money. Why does this matter? Again, it's hard to see humans purely relying on AI generated decisions and content without some form of checking or verification for a very long time. The next reality of the construction industry is that tools and processes can never replace execution on the ground. What do I mean by this? Well, say you're preparing a software program and you write a perfect bit of code generated by an AI. You run the code, it does exactly what you want. Construction just isn't like that. There's such a human element to it. So for example, you ask AI to generate the perfect schedule, the perfect estimate, the perfect project management plan. You don't have people who can interpret, adapt it, and lead it and implement it. It's completely worthless. Technology, as it stands now, can't replace judgment, leadership, and experience. You need people to implement the plans. And it's always AI, I believe, in the construction industry, until you've got intelligent machines and robotics that are doing all the work and there's no human element, it's always going to come up against this limit of how useful perfect documentation and plans are. Perfect implementation is fundamentally what matters, and it's hard to see in the short term or medium term how AI can support this when there's such a human element to construction sites. So to summarize, the realities of the construction industry is that construction is complex, high risk, and people driven. AI prefers clean, predictable environments. But with this important point I made at the start, that overhead and indirect costs are a huge portion of a construction project's budget. So there's a huge amount of money to be made for contractors who can reduce this portion of their project costs. So let's combine our understanding of what AI is, where the technology is likely going, and the realities of the construction industry to make some predictions in the short and medium term how AI is going to change construction. Here are 9 trends I believe we're going to start seeing in the short to medium term. The next important trend we're going to see, or I think we're going to see, is that the typical historic general contractor is going to lose ground. AI is going to put a lot of pressure on general contractors, which are basically project management organizations. As tools and software and systems get better at actually doing a lot of these tasks for us, the ability of a general contractor to put a 15% or 10% margin for managing trades, project managing a project, is going to be crushed. We're already starting to see this a little bit on major projects where owners are shifting to this model called EPCM, where the owner takes on the engineering, procurement, construction management, using tools to manage the design, the procurement, the construction. They're managing their own trades. And it's going to cut the management layer the general contractors put on and their profit margin. Basically, it's going to be cheaper to build stuff if you manage it yourselves using these AI tools and software rather than paying a general contractor to do it for you. The general contractors that manage these projects and rely on employing project engineers, project managers, contract administrators, cost controllers, these sorts of employees, and they don't self-perform the work themselves, I think you're going to feel a real squeeze, and it's going to be increasingly difficult for them to justify their margins. This is going to benefit owners. They're going to get more control of the project. They're going to be able to save money, and we're already seeing it in mining and energy mega projects where they already run lean with an EPCM model, and major building projects like data centers are already moving in this direction. I think you're going to see it more and more with smaller projects as you get better software that effectively allows you to manage the project yourself. Again, in line with this trend is I think you're going to see more and more labor hire and self-perform contractors. Again, till robotics gets a lot better, skilled trades are going to stay irreplaceable, but AI is going to be getting better at the coordination and driving of how they're performed. Again, in the near future, AI isn't going to be able to tie steel or pour a slab, but it'll be able to decide who should be doing it, when and where, which I think is going to lead to more of a rise in self-performed subcontractors completing small packages of works getting managed by a project owner directly, not via a general contractor. And same with labor hire companies where AI matches the crews, the scopes based on the weather, sequencing, the project updates, productivity data. Again, tools like Assigner are already being used to optimize subcontractor scheduling, and future platforms are only going to get better at doing this. The next trend, which I've already spoken about a little bit, where I thought the role of the contractor administrator would diminish, and I haven't really seen this playing out yet, but I think you're going to see smart contracts. You think effectively what a contract is. A contract is a massive rule book, and this role of reviewing the contract, interpreting what people have to do, it's going to get much more smarter and much more efficient, where contract automations are going to help reduce disputes. People are going to get paid based on objective measures from objective measurements. There's going to be set tasks that people have to perform. It's all going to get much more automated, much more simple and faster. Again, tying back into this where general contractors are going to struggle to justify their margins, it's going to get easier and easier to both manage subcontractors and subcontractors to directly work for owners. And we already are seeing some pilot projects using this. For example, in the UK, there's a pilot project which uses AI verification for milestone payments, and they think it's going to help reduce contractor cash flow delays by up to 30%. Anyone in the construction industry knows how important cash is in getting paid on time. So I think this is going to be a very positive trend. The next trend I believe we're going to see is more and more modular and offsite construction. Again, we've already spoken about how AI thrives in easy, repeatable processes like manufacturing. If we extrapolate this out, I think there's going to be much more prefabrication and offsite work where it gets easier and easier to manufacture stuff. And then our on-site work is going to be much more assembly, putting things together by designing, sequencing, and optimizing the builds. Factories thrive on repetition. AI is going to make real advancements in making it cheaper to manufacture things, which means more stuff on construction sites is going to get pre-manufactured. Site work is going to become much more about site assembly than construction. And if you look at the picture, that's actually a building being built in modular components. So all these separate apartments have been fabricated off-site, delivered to site, and they're simply craned into position. And again, as an extension of this, construction is going to move more from looking like a whole lot of skilled trades working in different areas to much more like manufacturing, putting stuff together. I've worked on a project where recently it was a major oil and gas project in Australia. Everything actually got built in Thailand. Then they shipped these huge modules to site. All we did is connect them up and hook them up together. Everything was done off site. And again, I think as AI gets better at these repeatable, easy to manage tasks, you're going to see more and more stuff built off site, less and less stuff built on site, and construction just going to look like doing the final touches and bolting things together. The next trend I think we're going to see in the near term is we're going to start to see the use of robotics on construction sites, but not by contractors buying their own plant. It'll be by specialist planners. I think robotics is going to come out, but there's going to be all these painful rules and regulations. It's going to be hard to set up, hard to optimize. You're going to start to see these specialist plant hire firms that specialize in construction robotics. So robots will hit the site like we would a crane hire, not like a co-worker for a contractor. You won't necessarily own your robot dog for site inspections, but you'll hire it from a specialist firm who combines both the upfront investment in the technology, but they're experts in setting them up, optimizing them, and using them. And also they organize all the maintenance and inspections. And it'll come into the construction industry in the shorter term as a service. To summarize, here's how I think in the near term, we're gonna see artificial intelligence play out in construction. We're gonna see changing project teams and job roles, less and less boring, repetitive administration work, and our jobs are just gonna get much more harder and challenging. They're gonna be much more about the human side, the chaos side of construction. I think general contractors, probably more over the medium to long term, are really gonna struggle to justify their margins as software and tools gets better at replicating their jobs. I think smarter contracts is gonna be a much better thing for the construction industry, much less disputes, much less late payments. Construction is going to move much more to modular offsite construction and more of assembly, and that we're going to see specialist robotic plant hire companies. So let's not get too carried away. We all know that the construction industry has a reputation of being very resistant to change. I want to finish off with some reasons why the AI adoption in construction may end up being much slower than we think. So I've already alluded to some of these major roadblocks, but I thought it's just worth recapping them because at the end of the day, AI thrives on structure and data, but construction offers chaos and context. So these are some of the reasons why I think the shift to AI and robotics might actually take much longer than we think. First one is messy and unstructured data. Yes, construction generates a lot of different documentation, but it's often scattered across calls, chats, spreadsheets, emails, and paper, and there's often no single source of truth. AI can't make good decisions if it doesn't have access to complete or clean inputs. Say, for example, there was a verbal agreement between a contractor and a subcontractor to work on the weekend, but the AI only sees the original program that was never updated. So when a subby invoices for the extra weekend work, the system automatically disputes it. The next challenge I see is that a lot of the learnings from a construction project, referred to as tacit knowledge, stay trapped in people's heads, embedded in their experience. So construction relies heavily on informal experience and judgment. That's what we referred to as good construction managers having a good gut feel or good experience, because they've dealt with these specific situations, although it may never be recorded anywhere. If it's never recorded anywhere and AI doesn't get access to it, it won't see it, it won't be able to use the information, which is so much of the experience and learnings from construction companies. Project manager might choose to avoid a certain supplier in tropical zones due to repeated failures they've had on past experiences, but without the pattern documenting it, AI is going to continue recommending the same product. The next challenge I see is that ultimately liability and responsibility for AI generated output is always going to still rest with humans. If AI makes a critical error, contractors are still legally and financially on the hook, and AI does hallucinate and makes mistakes. Insurers, regulators, your company's management aren't going to accept the AI did it excuse. For example, if you get an AI generated safe work method statement and it misses a critical step and somebody gets hurt, that's not going to be excusable. Someone is still going to have to review the output. Even if it's correct 99.9% of the time, it's still not going to be checked because it's such a high risk industry. At the end of the day, someone is still going to be liable and responsible for it, so someone will need to check it, which again, at the end of the day, is just going to slow everything down a lot. Related to this point is the unfortunate reality that AI can't be trusted blindly. AI tools can hallucinate, generating outputs that sound plausible but are factually wrong. In many cases, verifying the AI output can take longer than doing the work manually. So if you have an AI system that is, because they're probabilistic, if you have a system that is 99% accurate, to actually get it to 99.9% accurate is a 10 times improvement in the system. So actually getting these almost certainly correct AI systems is incredibly difficult and challenging. Why is it a 10 times increase? Because in the 99% accurate system, you have a 1% failure rate. The 99.9% system, you have a 1 in 100 failure rate. So you're actually reducing the failure rate by 10 times, which requires significant improvements in the models. Again, people are just going to have to check the work, and in a lot of instances, if you're going to have to check it anyway, you might as well just do it yourself in the first place because it'll be quicker and easier. For example, if an AI produces an estimate, but the project manager must cross-check it against site conditions, contract terms, and legal clauses, might just be quicker for them to do it themselves. The next problem with AI, and where I see it being such a big issue in construction, but the same issue that you can't trust it blindly, is when people start to get complacent and over-reliant on it, and you start to see big problems crop up, which is going to cause companies to push back against people using it. Once these AI systems are in place, teams may stop questioning and checking it properly, and in high-risk industries like construction, these blind trusts can lead to unsafe decisions, scope gaps, and major delays. For example, if a planner accepts an AI resequence program to save time, but fails to consider site constraints, leading to a subcontractor mobilizing on the wrong day and paying a delay, maybe the contractor gets charged with a huge delay, and then they stop using the AI tool because the 2 hours it saved the planner weren't worth the $25,000 delay claim. Okay, the next challenge I see is that currently the way construction projects are run is that there's a lot of different tools that don't natively talk to each other. So construction teams might have to juggle lots of disconnected tools like Procore, Aconex, Excel, WhatsApp, and Dropbox. And that is just a function of that every construction project is different. Maybe on one project, your client is using Aconex, and that's how they're transmitting you documents, but your document management system is TeamMiner. So for this project, you have to use Aconex, which doesn't work with the existing tools you've already got. So you have to set things all up from the beginning. Again, this is why I think this job role of the AI workflow engineer or the construction workflow engineer, whose job it is on each project to set up the unique specific tools and processes that are going to be used, is incredibly important. And the final reason is just because of the high risk nature of construction, I think there's a very strong natural resistance to change. Construction teams often resist new systems because the cost of failure is so high and the old methods still work. Every change you introduce causes disruption, causes a loss in performance. Maybe it's worth doing it because the tool's so much better, but maybe it's not. Even if AI did offer big gains, it'll still fail when teams don't trust the output, don't feed it clean data, and keep fallback processes just in case. For example, a contractor deploys an AI-based reporting tool, but supervisors keep entering all their information into their paper diaries. The AI is never going to be that useful. So you need a broad adoption of the tools. And in the construction industry, there is this huge resistance to change. AI in construction won't fail because it's not smart enough. It'll fail because the data is too messy, the tools don't integrate, and people don't trust it. So there you go. There's my 2 cents on how I think AI is going to change the construction industry. I think it's going to make a massive difference. That's why I'm making a big bet on it, and I'm investing my time in building an AI-powered construction estimating and contract management tool. I want to use it to make our lives easier and solve some of the real problems our industry faces. If you're keen to check it out, I'll put a link to it in the description of the video. Most people I know who use AI fall into one of 2 traps. They use it once, get a bad result, and decide unequivocally that AI is all hype. Or they think it will magically replace all jobs, use it to do absolutely everything, and never check what it produces. Truth is, as it stands now, AI is a tool and it's only as good as the person using it. For construction professionals, AI can help with faster estimating, writing scopes of works, and reviewing contracts. It can save you, if you know how to use it properly, hours and hours of work. So in this video, we're going to show you how to use these large language models to do valuable work. We'll cover how these models actually work so you understand their uses and limitations, and also how to prompt them effectively. And we'll finish off with some examples. What we're not going to be covering in this video is tools that embed AI like Procore or Autodesk, but also we're not going to cover how to set up AI agents and automation. This is all going to be done completely through the web interface of large language models like ChatGPT, Claude, and Google Gemini. Let's start off by talking about how these large language models work. A large language model is a mathematical model trained on billions of words. Books, websites, documents, the whole internet. They're like more or less an advanced autocomplete. They're trained to predict the next word, or as they use them, token in a series of letters. So what can they do? They can produce content, like they can draft letters, contracts, work breakdown structures, and schedules. They can summarize documents. You can upload a document into them and they can produce a concise summary. They can prepare explanations of complicated technical processes, and they can help you to rewrite scopes or schedules. They're capable of generalizing patterns to new problems, simulating step-by-step logic, and handling unfamiliar requests. Importantly, they don't think or know, they just guess incredibly well. So the interface of one of these chat models looks a little bit like this. Now, this is Claude, which is by far my favorite model, where you type into there, which is called prompting the model, and you'll get a text-based response. Some of the models like ChatGPT also produce images if you request them. So how do these models work? Well, they get trained on huge amounts of data. So a whole lot of data gets uploaded into these training models. The model is then a giant mathematical function that's produced from the training data, where they review all the patterns in the language. They create this giant mathematical model that captures all the patterns in the model. Then the model is effectively a prediction engine. They generate one word or token at a time based on the context they're given. They don't actually fundamentally know or understand, they've just identified all the patterns in the training data they're given. They also have a context window, which means they have their training data, the mathematical model, and then within the prompt you give them context around the task you want them to complete. And unless they're integrated into other tools, they don't have access to the internet or other tools like your calendar or Excel documents. Okay, so which large language model should you use? Well, there's a ton of different models out there, and there's lots of different ways to evaluate which ones you should use. Some are very expensive to use, some are cheap to use. Some you can upload huge documents into, some you can only upload small documents to them. Three main ones that I use are ChatGPT, Claude, Opus, and Gemini Pro. So ChatGPT I find best for general use. It's got strong reasoning, it's fast, but it has a relatively small context window. So 128,000 context is something like, I think, about 300 pages of text. Claude Opus is a reasoning model, which means it's a bit slower, but it's better at handling long documents and reasoning with complex tasks. It has a slightly larger context window. And then Gemini is probably the worst model in terms of its ability to reason and process information, but you can upload huge documents into it. So the way I would choose which model to use, if it's just general questions or information, almost always use ChatGPT. If it's a very complicated task where I'm not 100% sure how to do it, I want the model to reason and think through it practically. So I want to set up some new Excel spreadsheet for estimating and I have no idea how to do it. I'll use something like Claude Opus. I use Gemini if I've got a huge document I want it to summarize, because Gemini is probably the weakest model, but the best at uploading huge documents too. Okay, so what are some of the limitations of these models? Well, the first one is they hallucinate. Because they're not deterministic, they're probabilistic. If you give them the same prompt, you'll get different answers. Some of these answers end up being hallucinations where they're just completely incorrect. And for example, I've actually had this where I was at work and I was trying to look up an Australian standard for emergency lighting within a switch room. ChatGPT actually invented a fake standard and referenced information from another standard that wasn't relevant to my project, which made me look a bit silly. They also, when they do these hallucinations, they give them to you with incredible sounding confidence. They have no judgment. So again, they're just prediction engines. They don't fundamentally understand what happens. So they might incorrectly judge how important something is or remove a key clause. They don't really understand what you're trying to achieve. They just give, based on the prompt and the context you give them, they're always giving you the most likely response. They over summarize. They can lose context. You have to be aware of the context window, that if you've got some huge context window, you're uploading lots of documents, the chat can forget what's happening halfway through it. They can be inconsistent with formatting, and they can be because they're working on these mathematical predictions, or they are getting much better at maths, they're often not very good at mathematical stuff that we would think is quite simple. Okay, the final point I want to make about using these large language models is privacy and data. When you upload information into a large language model, you're sending your data to an external company. So if it's important contractual data, you shouldn't be uploading it to a large language model unless you have a custom-made one for your organization where you're using a private large language model. So don't upload full contracts, names of people, private information, because the data can be used for training new models if you're using them on a free plan. Next, let's talk about prompting. How do you instruct a large language model to do something so you get the best possible response? So this might sound a little weird, but the way I think about AI, it's like having access to Albert Einstein, but he's locked in your basement. He can't see your job, your project, what you're trying to do. He can only see bits of paper that you pass through to him. If you're vague, unclear, not specific, you'll get generic answers. You have to tell him everything he needs to know to be able to solve the problem you're asking him to. How do we prompt him effectively? How do we give Albert the information he needs to know to solve our problem? Well, the simple prompting formula you should use is you are a role, your task is to do XYZ, using this background context, return it in this specific format. For example, you're a contracts manager, review the attached subcontract and return a list of risks in a table. You're giving it a role, who you want it to be, a task to review the attached subcontract, and returning a list of risks in a table, the format you want the answer. So every prompt should have a role, who you want the AI to be, task, what you want the AI to do, context, what background information it needs to complete the task, and the format you want the output in. Now, the mistake I see people make when they prompt is that they blindly accept the output. To get the most out of AI, you actually need to know what you're doing. You need good judgment to be able to assess the response and re-prompt it. Most people prompt something once, they get a bad output, and they decide the AI isn't good at whatever task you've set it. The reality is, most prompts that I would do 3 to 5 revisions of it to get the best possible answer. I'll tell it what's wrong with it, I'll tell it how to improve it. You should prompt it, but then you should also be willing to go through multiple revisions to get the best possible answer from it. The worst thing you can do is just blindly accept the output, for example, some sort of report or project management plan that you just blindly send to your client without edits. So what are some traps to avoid with prompting? Is to blindly trust the output. You'll miss nuance, you'll miss important tasks. To give it vague prompts, you'll get generic results. To give it too much fluff, you'll confuse it and not pay attention to the important context. And so, in addition to needing good judgment to get the most out of these models and actually understanding the task you want it to achieve, there are some important traps you should avoid when using them. First one is blindly trusting them. They hallucinate, they make mistakes, they can also miss nuance. Maybe you haven't prompted it effectively, maybe you haven't given it the right context. Don't give them vague prompts or you'll get generic results. You give it too much fluff, you can confuse the model, use up your context window, and it'll miss important tasks. Also to remember that these models have this issue where they can become a bit sycophantic and always tell you you're correct, always agree with you and tell you you're correct. Sometimes adding to a prompt something like be hypercritical of my plan, I find to be incredibly effective. Some prompting techniques that will massively improve your output is that to show, don't tell, give examples of the type of output you want where possible, break down tasks as much as possible. More specific prompts will always get better results than massive prompts where you're asking the model to do 5 things at once. Use constraints, ask it to do something in a short amount of text, long, the structure you want it to be in, the tone. So for example, the hypercritical tone I find very useful. Use act as, that'll help give the model more context of what you're trying to achieve. Format your instructions and give it as much context, but not fluff, relevant to your task as possible. Let's wrap up by going through some example prompts of putting these best practices into action and seeing how, as construction contractors, we can take full advantage of the power of large language models. So the examples I'm going to show you are going to be in Claude, one of the large language models. Claude is my favorite one. I find it much better at reasoning and complex tasks than ChatGPT. To start with, I'm going to open a new chat, and these large language models remember context within a chat. So if you start a new chat, Claude will remember everything that happens in that chat. So if you're working on a new project, a new task, I would always open a new chat. First thing I'm going to do is I'm going to give it context about our project and upload the key documents. I told it I'm working on a project to complete HV terminations on a solar farm. Attached to the project documents, I'm providing this as context only, and I'm going to get you to help me with a series of construction management tasks. Do you understand? So I've uploaded the technical specifications and the scope of works. So Claude has said that it's understood, it's noted the documents I've uploaded, and done an assessment of them. So the first thing I'm going to ask it to do is, can you create a work breakdown structure for this project to help me understand the scope? And it's gone ahead and done that. I really like Claude as well because it generates documents. It's not just all in the chat window, but it's actually got documents you can give it feedback to and iterate on. So the first thing it's done, it's created a work breakdown structure for our project. We've broken down into project management, mobilization and start setup, procurement and materials. It's got listed out all the materials we need, the installation works, and blah, blah, blah. The next task I'm going to ask Claude to help us with is to prepare an estimate for the project. So I've simply prompted it, can you prepare an estimate for the project? And I've asked it to clearly show the working so we can check it. Again, it's gone ahead and done this. It's prepared a cost estimate for our construction project. It's broken it down into labor, materials, plant and equipment, subcontractors, preliminaries, and under each one, it's given quite a comprehensive breakdown so we can go through and assess this. Again, breakdown's important because we can then give it feedback and iterate. I'm not going to iterate through multiple revisions of the prompt now, but I'm just more or less showing you the capabilities of what these tools can do. So it's got a breakdown of how it's come up with the labor cost, what labor rates it's used, what crew composition it has, then the labor hours and how it's calculated that. It's got 2 hours per termination to prepare the cables, 6 hours to install the termination, an hour to test, so 9 hours per termination, 216 hours at the crew rate of 517 is how it's come up with the labor amount. Basically, you can go through and check this, you can give it feedback. You can always assess whether it's missed anything, whether the material costs look reasonable, and basically, here's a breakdown of the estimate for you to review. The next thing I've asked Claude to do is for a copy of the subcontract we've been given. I've asked, attached as a subcontract agreement our client has provided us, can you please review this and generate a list of clauses we should depart from? So it's given me a recommended departure schedule. It's listed out any of the clauses that have risk associated with them and what we should depart back and negotiate with them. For example, critical departures required. Clause 3, subcontract sum, fixed lump sum unless otherwise agreed in writing. Issues, no provision for rise and fall if the materials have a long lead time, no allowances for client caused delays, no provisional sums for undefined GIS interfaces. And it's actually given some incredibly good recommendations. It's gone and done this for liquidated damages, payment terms, defects liability period, and all the key clauses. The next thing that I asked Claude to do, and this actually shocked me how impressively it did this and how impressive the result was, but all I asked it to do is, can you now create a project schedule for this project, including a Gantt chart? And it went ahead and created this. Basically a fully interactive Gantt chart with clickable buttons. You can export the schedule, but it took the work breakdown structure, it's understanding the project scope, and it created a full Gantt chart broken down into mobilization, the terminations, the indoor terminations, testing, commissioning. It's actually got a drop-down menu. So I didn't prompt any of this. It did this all on its own, where I can look at just the mobilization phase, just the indoor termination phase, just the handover phase. It's also identified the critical path. So simply with a click of a button, I can change from milestone view to critical path view. It's highlighted all the key bits of information, such as the critical path, the 8-week project duration, and everything just off the single prompt. Can you create a project schedule? And again, we could give it feedback. We could ask it to include resourcing, to factor in public holidays, anything we can think of, we could ask it to make improvements. But I was really shocked at what it created with just that single prompt. The next thing I asked it after it created the schedule was ask Claude, based on the schedule, do we need to change the estimate to the schedule and the estimate align? Now, this is a useful check to do whenever you're estimating that if you've, for example, got an 8-week program with 5 full-time employees, does this actually align with the labor estimate you've come up with? Claude has done this assessment. Based on that prompt, it's determined that the labor hours were estimated by 100 hours based on the schedule hours versus the estimate hours. There's a cash flow crisis at week 7. Again, I didn't prompt it to check cash flow. I've just simply prompted it, based on this updated schedule, are there any changes to estimate? And again, it's given us a full report of this sort of investigation. Again, if you tailor the prompts, if you're more specific with exactly what you're looking at, you'll always get better results. And the final use I've got for our project is we've done the schedule, we've done the estimate, we've reviewed the contract. Say we're starting works and we need to generate an inspection and test plan. Simply prompted it, generate an inspection and test plan for this project. And here we go. It's gone and created an ITP. Now we'd obviously have to check and review this, make sure we've given it enough context, make sure it aligns with what we're looking for. But in literally seconds, we've created some very useful construction documents that probably in the past would have taken us a day or two to generate. Those were just a couple of very simple and straightforward use cases, but you can see the incredible power of these tools for construction managers. It really comes down to our creativity and our willingness to use them. Again, you have to remember that these models can hallucinate, they can make mistakes, so you always need to check what they're actually producing. You can get a little bit caught up or drawn in by how impressive the displays are, how quickly they do it, but there is a very serious chance that these models make mistakes, so you do need to check what they're producing. Here's 10 unbelievably simple ways construction contractors and construction managers can start using AI tools today to help you win more work and deliver it profitably. Number 1 is AI generated meeting minutes. Meeting minutes is one of those things we all know we need to do, but we never end up doing because we always have more important stuff to do. You can use a tool like Firefly's AI, connect it to your Zoom account or Microsoft Teams account, and it'll auto-generate meeting minutes that'll help you resolve disputes with your clients and subcontractors, clarify scope, and manage actions with your team. Number 2 is to help you with your construction estimating. You can prompt large language models like Claude or ChatGPT with your project's context to summarize tender documentation, prepare a budget estimate, create a work breakdown structure or task list, document your assumptions and qualifications, or error check and review your estimate. As an example, using Claude, the Anthropic large language models, I've prompted it, attached as a construction tender, I'm preparing the estimate and need your help. Can you please summarize the tender documents into concise dot points detailing everything that impacts pricing? Now, this was a small tender, but often, as we know, we sometimes get construction tenders with 30, 40 documents, thousands and thousands of pages. So reviewing them all manually, it just isn't feasible during tender timeframes. So this is an example where I've just asked it to analyze the tender documents and summarize the key pricing impacts. It summarized the supply requirements, labor and expertise costs, testing and commissioning. We have to do insulation resistance testing, partial discharge testing, VLF testing. Quality and compliance, we need a 40-year design life, we need a 24-month warranty. So rather than having to go through all these documents manually, it's produced a concise summary that we can refer to. Next, I've asked it, can you prepare a budget estimate for this project? So based on the context, the tender documents, I've simply asked it to prepare an estimate, and it's gone through and it's broken down the entire project into material supply, earthing and bonding, safety and environmental, all our labor costs. We need a project manager for 320 hours. Now we could assess and check all these, and we'd probably have to give it some feedback and iterate through to improve this. You can see it's actually gone ahead and produced us a complete cost estimate based on that single prompt. The next thing we can use these large language models for in AI tools is for scheduling. And when I was researching this video, I was actually a bit shocked at how incredibly powerful these tools are at schedule. So based on simple prompts like based on the attached project scope, create a work breakdown structure, group it into design, construction, and commissioning, link the activities, put it into a format you can export to Microsoft Project or just the generated Gantt chart. Claude actually went and generated a fully interactive, clickable Gantt chart. Based on this simple prompt, can you create a project schedule and Gantt chart for this project? Again, I'm previously given it the project context when I asked it to prepare the estimate. Claude went and created a fully clickable and interactive Gantt chart, a detailed project schedule based on our 8-week duration, start and finish date, a breakdown of all the different activities, the resources required for them, and this Gantt chart showing what's happening in each week and also what the critical path is. Again, we could prompt it, we could iterate through this and improve the output, but based on that single prompt, in a matter of seconds, it produced this, which I think is absolutely amazing. Next, we've got a site diary. Now, this is more of an automation rather than strictly artificial intelligence, but I built in about 30 minutes a simple automation using Airtable with a couple of different databases and tables and a form to collect information, and effectively recreated a simple site diary where you can enter what work was done each day, the weather, upload photos, and record all your progress quantities, your labor hours used, all your timesheets. And it took me about 30 minutes to prepare. If you're not familiar, Airtable is like Microsoft Excel on steroids. It's a web-based app that effectively allows you to create different data sets and then to link them to forms and interfaces, as well as integrate some integrations. It's just much easier to use than Excel for this type of work. It allows really easy linkages between data tables without complex VLOOKUP formulas. So this site diary, all it really is a form which the user can fill out. So this is the site diary form. You enter the date, the status, supervisor, weather, who the different members of your crew are, what work they've done, what cost code they were working under. So, and then the quantity of work completed. It stores all this in a series of databases. So we've got the site diaries, all the labor hours tracked, all the quantities of work recorded, and then it sums this against each of our cost codes. So we might have a cost code for site excavation that has a budget quantity of 500 meters cubed and 200 budgeted hours. And each day when people log their timesheets, it tracks the hours worked against each cost code, the quantity completed, and then it reports the quantities logged in quantities. So the percentage complete of quantities and a percentage complete of hours used. Now I built this in about 30 minutes, maybe even a bit less. I put it into a simple interface where users can just see for each of our cost codes, it reports on these budgeted quantities, the percentage complete, the total quantity of work, the total quantity logged, and the total hours. It's super simple. You could add some much more fancy visualizations. You could track which diaries are completed, what days they're open, who needs to review them. If you put a little bit more effort into it, but you can very simply and quickly build these tools that a lot of the big construction management software companies charge $50,000 a year for. Another use of AI that is incredibly powerful, if you ever spent hours tracking through your email inbox, trying to look for that email where your client told you to do something, or a subcontractor read something with you, again, using Airtable, you can set up a simple correspondence tracking sheet where all your emails for a project, you just set up a project email address that's stored and recorded in Airtable, basically giving you a searchable database of all the project correspondence. Again, some of the construction management softwares charge $5,000, $10,000, $15,000 a year for tools like this that you can literally build in 20 or 30 minutes. The next use case, which is probably the most obvious one, is that with these generative AI tools that are designed for generating new information, you can use AI to prepare your inspection and test plans, inspection and test check sheets, your safe work method statements, your schedules, as we've already seen, or your project management plans. The massive caveat I'm going to give is that you need to review these incredibly carefully. You can get a little bit lulled into the trap of thinking how confident and powerful they are, but these models do hallucinate. And I've definitely seen some very simple, hard to believe mistakes that they do generate. So you just always need, they'll probably do a good job 99% of the time, or 95% of the time.
You just have to be very careful about checking the output, particularly if it's critical, it's got safety implications, it's got cost implications, or you're sending it to your client. Again, if you're using the tool, the liability rests with you. The next tool we can use these for as construction managers is contract reviews. So even the simplest construction contracts are often hundreds of pages long, contain 20 different attachments. At the end of the day, these contracts aren't actually meant to be user-friendly or easy to use. They're meant to be bulletproof. So AI processing, getting them to summarize these documents, getting them to review them against the key clauses is an incredibly practical and easy to use application of these. It can save you a lot of time doing it yourself or having to pay a lawyer to do it for you. The next way we can use AI as construction contractors and managers is to basically learn new concepts. One of the biggest challenges in construction is even if you're building a simple building, there's so many different technical concepts you'll need to understand. You need to understand civil engineering, mechanical engineering, electrical engineering. You'll need to understand different codes and standards. You'll run into difficult faults or complex technical issues. Use AI as an enhanced Google search to teach you new concepts very quickly. Use prompts like, I have no technical experience, explain this to me very simply. And then you can quickly understand complicated concepts in electrical engineering, civil engineering. For me personally, I'm an electrical engineer, but I've done a lot of concrete and civil construction. And I've found AI so useful at understanding drawings, putting in screenshots of different drawings or details I don't understand, and getting it to explain it to me simply. The next use case that I've been playing around with a lot recently is getting AI to play the devil's advocate. What I mean by this is basically using it to stress test your assumptions or the work you've created. Say, for example, you're submitting a variation to your client. You want to claim extra money for a delay that they've caused. You can use AI to help basically take on the role of your client and ask it to pull apart the variation and be hypercritical of it. And then rather than having to go through that with your client, go through it with the AI first, make the improvements before you submit it to your client. And as an extension to this, you can actually use AI to review your work. Think of it like some sort of universal spell checker that you can take out of Microsoft Word. For example, you could prepare your construction estimate in Excel, do it yourself, simply upload it into AI, ChatGPT or Claude, and ask it to do a comprehensive assessment of your estimate to identify any gaps, make sure it aligns with the scope, identify if you've got any calculation errors. So there you go. There are 10 super simple, quick, and effective ways you can start using AI today.
What if 90% of your day didn't have to be admin? No more chasing paperwork, filling out reports, or copying information from one software or one spreadsheet into another. Most of the time-consuming tasks we do in a construction project, filling out reports, recording data, sending updates, can be fully automated. And when you free yourself up from this repetitive grunt work, you get more time to solve real project problems and drive the project forward to get better cost, time, and schedule outcomes. And what's even better, most of these tasks can be automated with simple or low-cost automation platforms like Zapier or Make.com, and you don't need any coding experience to do so. So in this video, I'm going to give you a complete guide to automations for construction managers. I'm going to walk you through why you should care about automations, what they actually are, 5 game-changing, incredibly simple construction automations we can build together, tools you can use to then implement these automations. Then, most importantly, how to think like a workflow designer and some key takeaways and next steps so you can start implementing these on your projects. So to begin with, why should you care about automations? And it's not really a topic anyone talks about in the construction sector. Yes, we have software that effectively has pre-built automations, but no one's really talking about these do-it-yourself custom automations and the platforms that allow us to build them. Advances in no-code tools and AI large language models are making automations easier and easier to build and smarter and more capable. Construction managers, site managers, project engineers all drown in repetitive administration work. Our days are filled with logging site diaries, sending daily reports, filling out RFIs, tracking and reviewing subcontractor claims, updating schedules, following up on outstanding tasks and preparing meeting minutes. This work, as we all know, is incredibly boring, but it's not optional. It's absolutely essential to the success of any construction project. Administration is unfortunately what keeps our projects running. A manager once said to me, a good project is a boring project. And what he meant by that is that the chaotic, stressful firefighting is always a bad situation to be in. The repetitive, mundane, boring, busy work is what happens when everything's going according to plan. But this mundane, repetitive, busy work is absolutely essential to the success of any project. The real problem lies that we end up with so much of this repetitive, boring admin work that we don't actually have the time to focus on the tasks that matter. We don't get enough time to plan, prepare, and manage risks and look forward. Or even worse, we don't keep up with this administration burden and critical records fall through the cracks. Enter automation. No-code platforms like Zapier, Make.com, and N8M allow you to connect the different tools we use on construction projects and then allow us to put in simple step-by-step processes that automate these tasks. When somebody goes on site and takes photos, we can automatically upload these and store them in the correct folders. We can create an auto-generated site diary where a form is simply filled out, sent to someone via WhatsApp, they fill it out, and then we automatically create a weekly report. We can automate setting up reminders when an RFI hasn't been responded to, and we can automatically sync data between our cost tracking and our estimating database. All this busy work can be very easily automated. Now enter artificial intelligence. We can make our automations smart. Automations no longer have to be set step-by-step workflows. We can integrate intelligence and decision making into them to make them much more powerful. We can now do things like auto-generate meeting minutes after every meeting with tools like Fireflies. We can create draft contract letters when a certain series of events happen. Say for example, we get a couple of days of inclement weather. We can set up an automation with AI in it that automatically generates a delay notice in accordance with our contract. We can use AI to continually be managing all our project documentation, looking forward and updating our risk register. And we can use AI and automations to track all the project correspondence and generate reports or insights into actions we should take. Unfortunately, repetitive busy work should be a thing of the past, but it isn't. Using automations and learning how to use these platforms is going to make you incredibly powerful at managing this sort of work. To really show you the power and capabilities of some of these tools, I'm now going to walk you through 5 example automations. These are basic, I put them together incredibly quickly, they're not very sophisticated, but it's just there to show you the power of what you can do. Now, to build these, I'm going to be using 2 main tools. Zapier, which is a no-code automation platform that already has existing links to thousands of different softwares. The other tool I'm going to be using is Airtable, which is like a Microsoft Excel on steroids. It's much better, much easier to use, and it's already got some really good integrations with tools like Zapier. You're not going to need to know anything about APIs or any other fancy coding techniques. To start with though, I want to give you a framework to first understand automations. Every automation has 3 core components. A trigger, which is what sets off or initiates the automation. This could occur when somebody submits a form. Say for example, someone's filling out a site diary, when somebody sends an email, or it could trigger on a set recurring period. Maybe it runs every day, every week, or every month. After the trigger, we then have an action or a task. This is what should happen in response to the trigger. For example, somebody fills out a form, the action is then to generate a report, store the data, or send an alert to somebody. This is where the data gets transformed. The final step is the output. What is the end result of the automation? Does a new record get created in Airtable? Do we send an email, or do we generate and store a file? So any automation you're looking at is always going to have these 3 components. There's going to be something that starts it, a trigger. There's going to be a series of actions and tasks that the automation performs. And this is more or less transforming the data. And then we're going to have an output. What's the end result? What is the automation creating? The first automation I completely built in Airtable, and how it works is it's basically a simple construction site diary. We get a form, our daily site report, where the project engineer or supervisor can fill out project information, status, weather, temperature, general notes, upload photos. Then for all the people working on the project, they can track the hours they've worked and the cost code they've worked under and the quantity of work complete against each of these cost codes. So excavation, reinforcement installation, concrete placement. This data is then all stored in our Airtable data records. So for example, for each of these diary entries, we get a new record installed, a new record in the table where we recorded what activities took place, who was working, how many hours they've worked. We can extract from that summary information against each of our cost codes. So rebar installation, site excavation, concrete placement. We've got a budget quantity, a budget number of hours. Then we can look at the total number of hours worked against that cost code, the total quantity completed, the percentage complete of the quantity, the percentage complete of the hours we've used, and we can calculate our cost performance index against that. And then finally, display this all in a very simple dashboard where we look at the hours worked against each task, the total, and present the key metrics to management, and also show some key graphs and charts and summary numbers. Now, we can extend on this and integrate some basic automations from Zapier. So the second automation I've created is a weather tracker. Tracking weather, it's incredibly important on construction projects because maybe in the contract you've got some allowance for inclement weather, and if you exceed those allowances, you're allowed to claim delays. But the only way you can do that is if you're tracking and recording any downtime loss from weather. So this automation runs every day. It gets the weather report and it stores it as an Airtable record. So I've added that as another table in my Airtable automation where every day I'm tracking the weather. All it's recording is the temperature and a brief summary, but you could extend this to record average rainfall, total amount of rainfall, total numbers of rainy weather, and basically justify any time you've lost. Again, it takes 20 minutes to set up and it can run for your entire project. The next automation I've created is going to take the records from our site diary. So it's going to use this data we've got from all our diary entries. We're going to use it to generate a progress report. So what it does is it runs every week on a Friday afternoon. We take our, 3:30 p.m. on a Friday every week. It's going to take our site diary information and it's going to use ChatGPT to transform this into a progress report that then gets sent as an email to our manager. So what we do, we set it to run every week on a Friday afternoon. We search for the relevant records in Airtable, which basically are all the records for the preceding 7 days. We then use a simple prompt to take these records as context. Then we give the instruction to ChatGPT. You're a construction project manager creating a weekly progress report, analyze the site diary entries, and create a professional progress report for the week. We want an executive summary, a summary of the work completed, any issues and delays, safety and quality, resource summary, upcoming weekly priorities, recommendations. Very basic. You can, again, tailor it and adjust it as you want. I've set these up in literally 20 minutes, so they're incredibly easy to create. And the final step in the process is it's going to send me every week an email with a summary of the work we've completed. And here you can see an email automatically sent from Zapier. It's ended up in my email inbox, giving a weekly progress report for the Downtown Tower project and mall renovation for the week ending the 1st of August 2025. It's giving me an executive summary, the work completed this week, issues and delays, safety and quality, resource summaries, upcoming week priorities. Again, incredibly simple. We can change the prompt, we can change the information it gets as context, but we can tailor this to provide the information or automate the task we need to complete for our project. The next automation I've created would save you hours on projects is a simple correspondence tracker. Now you can buy incredibly expensive construction management software like Aconex or Teambinder, which effectively does the same thing. But what this does is it tracks all your project emails. You could set up a dedicated project email address or a dedicated operations or projects email address. All the emails that get sent to that inbox would then be stored in an Airtable database, which this database you could then use to quickly search for things, to provide context to large language models. If you get into a dispute with your client, you could quickly find all the emails that client sent, all the instructions, all the attachments. So tracking correspondence is unbelievably important, and I've spent a lot of time hunting through my email inbox, finding for when things are agreed to from our clients. So something like this can save you a ton of time. It's unbelievably simple. It's unbelievably simple to set up. All you do in Zapier is every time you get a new email, which I've set up using my email address, every time I get a new email, I create a record in Airtable, which details the email, the subject, the body, the date, and the time. Then every time I get an email, it'll store it as a record in Airtable. I guarantee if you set this up once, it will save you $50,000, $100,000 the next time you get into a commercial dispute and you're hunting through your emails to try and find when something was agreed to or why you did a certain thing. Unbelievably powerful, but you can literally set it up in 5 minutes for absolutely free. So for my final example, I've got a slightly more complicated automation. The goal of this is when you get sent a new tender from a client, you might get PDF drawings, Word docs, scope of works, an Excel bill of quantities. We get sent a whole lot of different documents, and you basically want to quickly understand what the hell your client sent you. So the goal of this automation is for all this different documentation you get sent, you can quickly upload it, get all the documentation combined into a single context, and then send it to ChatGPT or another large language model to complete a quick analysis and give you a summary of the documentation you provided. So basically how this works is you get sent all your documents, you upload them into an Airtable form, breaking them down by the tender, the scope of works, the contract, the drawings, and so on and so forth. It iterates through all the different files, combines them into a big text file, so the PDFs and the Excel all need to get converted into a text format, stores them again in Airtable, and then I'm going to set up another automation where it automatically sends this to ChatGPT or another large language model and converts it into a concise, structured tender summary. So I get sent 15, 20, 30 documents. Automatically, I get an email in my inbox, which gives me a concise summary of what I've been sent, and so I can start to quickly digest and start responding to the tender. The purpose of this was just to give you a quick and dirty overview of what these automation software look like and the type of things we can start to automate. They're not perfect, they're just some very simple concepts, but again, start experimenting with tools like Zapier, start seeing what you can automate, and you'll be shocked at how much the repetitive, boring administration work you can begin to remove. When you hear about some of these tasks like automated site diaries, correspondence trackers, or weather trackers, you'd assume you need some sort of coding or computer science skills, and that used to be true in the past. Now you can build them all without a single line of code. You just need logical thinking and some basic understanding of different data structures. Really, the most important thing is the correct stack of tools. Think of the tools you need in a series of layers. You've got where the data comes in. So these are things like forms, emails, PDFs, schedules. What moves the data around, which is the automation platform. What enhances the data, which are things like AI models used for summaries or formatting, and where it ends up in trackers, in folders, or as emails. Let's quickly talk about which automation tools do you need. The first one is the actual automation platform itself, the thing that's moving the data around, completing the tasks. There's really three main platforms out there: Zapier, Make.com, and N8N. Zapier is by far the best one to use for the type of tasks you're going to be completing. It's easy to use, it's got 6,000 pre-built integrations, so you don't have to mess around with custom integrations using APIs. It works with Gmail, Outlook, Slack, Airtable, Google Docs, Jotform, Procore, Asana, and I think there's also a Primavera P6 integration. It's perfect for simple administration tasks, logging emails, syncing entries, auto-sending documents, and it is by far the best one and the one I'm recommending using for construction managers. Make.com is another popular one that I've experimented with. It's pretty easy to use. There's not as many pre-built integrations, so you'll need to use APIs to integrate them. It's better for more complex multi-step workflows like delay notifications, document generations, and summary reports. It basically allows you to do more complicated workflows. Once you start building more complex workflows in Zapier, I feel like it struggles a bit and it's a bit more challenging to use. The final tool, which is the one that's more or less used by a lot of these specialist automation agencies, is N8N, which is an open source tool, but it has a much steeper learning curve. and you almost need to understand computer or software development to be able to use it. I tried using it to build my tender analysis tool and I got way too confused. It was much more difficult to use. The next thing you're gonna need is some sort of data source and storage. Now, there's a couple of different tools you can use. The most familiar of them being Google Sheets or Microsoft Excel, which using Zapier, which allows you to talk to your Google Drive and your documents, you can quite effectively actually just use Google Sheets or Excel online for using this. The one I have found the most useful and the most powerful is Airtable, which is again very similar to Excel, but it's purposely made for integrating in these sorts of workflows. You saw the example I did with a construction site diary. That took me literally 20 minutes to build. It's perfect for site diary logs, correspondence trackers, tender trackers. You can use it to track subcontractor quotes, safety checklists, and it also allows you to very quickly generate forms. The next sort of data source you could use is different types of form building software such as Jotform, Typeform, or Google Form. They can be a bit more customizable than the forms that you're allowed to build in Airtable. But again, if you're using Airtable for your data, I would just use Airtable forms. And yes, Google Sheets and Excel, you can begin to integrate with these. I just find Airtable way more simple and easy to use because it allows all your different tables to integrate seamlessly. If you're trying to do this with Excel or Google Sheets, you need complicated VLOOKUPs and formulas, which if you're good at using Excel, you can probably build quite easily. But if you're not great at Excel or you want to be able to do things simply and easily without having to worry about tons and tons of errors and writing 30-line formulas, I would just stick to Airtable. The next tool you'll need is some sort of large language model or AI integration if you want to integrate AI into your workflows. Now, the most common of these are OpenAI, ChatGPT, which everyone knows about. There's also Claude, which is Anthropic, which is the large language model I use by far the most because I find it just much better at complicated tasks and reasoning. I like the style it writes in. And then you've also got Google Gemini, which Google Gemini I haven't used much, but one of the advantages of it is it allows you to provide a huge context window. So you're allowed something like 1 million tokens, which, for example, I've uploaded a 600-page contract into it and it's done a full analysis of that. That's roughly, compared to Claude or OpenAI, the context window is around 5 times the size. The final set of AI integration tools are the tools that are built on top of these large language models. For example, if you're doing meeting minutes, something like Fireflies will auto record and summarize. If you want to do research on the internet, you can use something like Perplexity. So often these tools you can also integrate. To quickly recap, to build great automations, you'll need a stack of tools. You'll need something to capture data, which is a form or a site app, which you can use for Airtable, you can use Google Forms. You'll need something to store and track and manage your data, Airtable, Google Sheets, Excel. You'll need something to move and process the data and actually complete the steps in the automations, which is the automation platform like Zapier or Make.com. If you want to generate insights, add intelligence to your workflows, you'll need a large language model, and then you can then integrate these with the existing tools you already use. For example, if you use Slack for communication, use Gmail or Microsoft Teams, you can then integrate these external tools into your workflows so they can do valuable and meaningful work. So far we've spoken about the different tools to use, what automations are, and given you some example automations. I quickly want to finish off by talking about some more general principles about how to think through and how to design these automations. Because if you start trying to build one of these automations, particularly if it's complex, you start playing with Zapier, integrating tools, and you haven't really thought through critically and systematically what you're actually trying to automate, what the steps are, what's happening to the data, it's going to be 10 to 20 times harder. And from experience, I can tell you, you'll basically spend hours building the thing, then decide halfway through it's wrong, go back, try to change it, and you'll keep going through this painful iteration process. It's not just going to work. So before you start building any of these automations, just sit down with pen and paper and map out exactly what's going to happen. And I'm just going to quickly talk you through how to go about doing that. We're going to look at very simply how to understand the inputs, the outputs, and the data transformation. So how do you transform a boring, repetitive task into something you never have to do again? Step number one is you need to identify what the repetitive task is. You should ask yourself questions like, what do you do more than once a week? What do you do on a recurring basis? What tasks feel like admin but are critical to getting right and getting done on time? Or what do you dread doing manually? Automations are perfect for anything that's repetitive, done on a regular weekly, schedule, or triggered basis. They're administrative heavy. You're copying and pasting, you're retyping, you're checking. They're essential but low value, like logging data, sending routine emails, and they're prone to error if they've forgotten. For example, as we've gone through, logging weather or daily site conditions, preparing and sending weekly progress reports, reviewing subcontractor compliance documentation, or tracking correspondence. Again, when you get started, don't be too ambitious. Pick something very simple and work out how to automate it. Second step is, so once you've identified the repetitive task, is you need to identify the trigger. Each automation, as we've discussed, has an automation trigger, which is what kicks off the workflow. There's three main types of triggers. There's a manual trigger where you start by clicking a button or run it on demand. For example, you submit a form in Airtable. There's a scheduled trigger, which is something that repeats on a regular time basis, so every day or every week. So every morning at 7 a.m, we fill out the site diary from yesterday, or every Friday at 4 p.m, we send a report to management. Then there are event-based triggers. So these are triggered by external events. Forms filled out, an email is received, files uploaded. For example, when we receive a tender package, that is the other type of, that's an event-based trigger. Once we've worked out what we're gonna automate, we've identified the trigger, we need to map out the workflow. So before we automate anything, we need to clearly understand what's coming in, the data coming in, what needs to happen to it, the processing or transformation of the information, and where it goes, the output. Bad automations fail because the data is in the wrong shape for the next step. Once you start playing with these automations, you'll understand how important different data formats are. I can't stress that enough. So, what's the type of input data you'll receive? It might be a site diary form, which is got structured fields that you can break down. There might be a field for weather, hours worked, the quantity of work completed. That's a structured format. You might get a PDF, so an unstructured document, which will basically just be a whole chunk of text. You might get an email, which will be broken down into the subject, the body, the attachments. You might be integrating with external tools like using a weather API, and then you can look at the data that they provide. They might provide the temperature, the rain, the wind, or you might get a spreadsheet with certain rows and columns with data in it. So you need to understand what format the data is in to begin with. Then you need to ask, is the data in the correct format for what you want to do with it? For example, if you want to send all your site diary records to ChatGPT, you can't simply link your Airtable table to ChatGPT. You need to extract the data from it and get the correct data to provide it as context to the model. So you have to look at, is the data structured? Does it need to be cleaned? Do blanks need to be removed? Does it need to be filters? Is there essential information missing? Do you have to link records? So you have to get the data in the correct format. Again, this is where you often run into problems where you might get something like an unstructured document and want to extract something specific. These are where the real challenges in these automations come in. You need to format data for different types of date, or time, or number formats, split it or join fields, add default values, or convert between formats. You need to map out this data flow to understand what data is available at each step in the automation. The next question you need to ask is, does it need, based on these data formats, and you understand the different formats that are available, does it need processing, calculation, or some sort of AI help? Do you need to calculate anything? For example, if you have the quantity worked, the hours worked on a certain cost code, you don't automatically have the cost performance index. You need to create a formula in Airtable that combines the two to calculate the CPI. If you've got a huge document, do you need to generate a summary? Do you need to process it with some sort of ChatGPT prompt to condense it or categorize it? Or do you need to tag or categorize the different sorts of information? Does it need to be grouped by project or by a certain time period? So some examples of this sort of data processing you might do is you might want to generate a summary of a site diary or a whole lot of free text fields and turn them into a condensed summary of what happened during the week with AI. For weather tracker, you might get the raw rain data, but you want to categorize it as whether it's been a wet day or not. So you use if it's rained more than 5 millimeters, we classify it as a rain day. You might want to get some sort of tender log. So you might need to know the date the tender closes, but you get given an unstructured PDF from your client or some sort of email or different text formats. And you want to find for all your different tenders, what is the tender closing date. So you probably need to process that with some sort of AI call, or you need to review a different variation from subcontractors. Again, because all subcontractors will probably submit their variations differently. Some will submit them formally, some will submit them as emails, some will submit them as text messages. You'll probably need some way to extract the relevant information from that. Once you understand what data has come in, you need to understand where the data is going and what format you need it in. For example, if you want to, at the end of your workflow, you want to send an email, you'll need some sort of text to go into the body of the email. If you want to update a row in your database or your Airtable, you'll need some sort of structured text, number, date, or status value. And you'll need to understand the specific format the tool you're using needs it in. For Google Sheets, you need to understand where the data is going, what format, is it a number? To generate a PDF, do you need a pre-filled template and then to fill out certain sections of the PDF, or to send a Teams or a Slack messages, you'll need to format it as a message. So these workflow designs don't need to be complex, but I can't stress enough that you need to work step by step through the process to understand what data is coming in and what data is coming out. So for example, as an example workflow design, the first step is a form submission. So a site diary with the date, the supervisor, the notes captured in an Airtable form, and the trigger is when the form is filled out and the user presses submit. We then need to format and clean the data to remove empty fields, standardize the dates if we haven't set up our original data capture tool to ensure that the users are doing this. We then, every week, want to use and summarize this information using AI, which will give us a text output, or what the call to ChatGPT has given us. Then we want to review this summary before we send it to our manager. So we want to add another status label to each of our fields, whether we've reviewed it or whether it's incomplete and ready to send. Then the output is to email it to our client and log it into Airtable. So this might be something we have to break into 2 automations, or it might be something we can capture in 1 automation. Key here is you really want to understand what data is coming in, what's happening to the data, and what is the end result you're trying to create, and what format does it need to be in. So I hope that helped. Again, the only way you can start to feel and actually capture the power of some of these tools is you need to start experimenting with them. The examples I gave were super basic, quick and dirty, and they were there to showcase roughly how these tools work and how you can begin to use them. My strong recommendation is the only way you're going to really understand how to use them for your business, for your career, is to begin playing around with them.
Everybody in the construction industry loves to talk about data, that we need more of it, that it's the key to project success, and the future of the construction industry relies on data. And with the rise of artificial intelligence, the hype is only getting louder. Here's a question that I think most people couldn't actually answer. How does data help construction contractors make more money? Or are we just collecting spreadsheets and site diaries that are never actually used? In this video, I want to give you a framework to explain how contractors and construction managers can actually use data to drive better project results. I'll be covering why data matters, why managing data on construction projects is inherently very difficult, why data matters even more now due to the rise of AI, what good construction data practices look like, and a practical guide to managing data on a project. So to begin with, I want to unpack this question of why data matters because I don't think it's immediately obvious. And I think most of the people who talk about how fundamental data is the future of construction haven't properly thought through the question. Because the real question at the end of the day is, how do data and records help contribute to the success of construction projects and construction businesses? I'm not going to go down to the specific level and specific use cases. I'm going to talk more about the general principles behind why data is actually incredibly important to the success or failure of construction projects. There's 6 fundamental reasons why managing construction data is important, but also going to become increasingly important as time goes on. Number one is better data means better commercial decisions, better decisions about the contracts you sign, the decisions you make to execute the project, how you spend money, and how you complete the project faster. For example, what it means is you're able to use real numbers and real data, not gut feel. So you can use data for better variations approval. You can substantiate your variations with records of what happened every day on site, when emails were spent, when correspondence happened. You can use better data for better subcontractor or supplier evaluation to look at historically how they've performed. You can use data to better plan your cash flows when you're spending money, map it against your actual payment terms and the payment terms of your subcontractors. Reason number two is to monitor and control the performance of your project, to really assess whether your project is being run well, whether it's going to make money, or whether it's going to lose money. Fundamentally, monitoring and controlling your project, the principles of earned value management, cost and schedule tracking and reporting, and generating insights comes down to the data and the accuracy of the data you record. You can use your cost data to compare how you're spending money against your budget, whether you're 15% over on formwork, and identify ways to fix it, how you can use it to manage the time or when you forecast to finish the project, looking at weekly site diaries, the quantity of work total from the drawings, the quantity of work you've completed, how long it's taken you to complete this, what resources you've had allocated to these tasks, and also look at data to help you manage safety and quality. You can look at the defects, the type of defects you're getting, when these defects occur, how they're getting closed out, how long they're getting closed out, how many defects you've got left. You can basically, by recording and analyzing this data, you can actually start to paint a picture of how your project is performing, not subjectively how you feel people are managing it, but objectively looking at concrete metrics to assess whether it's a well performing project or an underperforming project. Instead of just simply using it to monitor and control your projects, data helps you forecast what's likely to happen in the future. Now, this idea is obviously very linked to point number one, which is better commercial decisions. But data is the basis of how we forecast what's likely to happen in the future, and then we can plan, prepare, or even prevent things like this happening. For example, we can look at by tracking labor productivity across projects in the time of year, we can show that concrete pour productivity is lower in winter than it is in summer, and we can use this to integrate it into schedules going forward in the future. By logging all of our weather, we can accurately estimate how much downtime we're likely to have on different projects throughout the future. By logging our subcontractors' performance, we can determine whether this subcontractor, the estimates, the schedules they provide us are usually on time or longer than they anticipate, and accurately forecast buffers for doing this. So, data can be used to forecast what's likely to happen in the future. Data can also be used to protect you in the present. What I mean by this is good data is essential to protecting yourself commercially, both in disputes you have with your client and disputes you have with your subcontractors. Using data, you can prove what's happened, prove what's been agreed to, and instead of ending up in he said, she said situations, trying to blame another person or argue something, you can always revert back to the facts. But the only way you can do this is if you record what's happening on your project and you have accurate records. Who said what happened on this date, what was agreed to, how long something actually took, how long something's likely to take in the future. You can use it to resolve delays, subcontractor variations. You can use it to substantiate variations you're making to your client, defects, how long these defects are being taken to close out. Basically, the more data you have, the more records of who said what, of correspondence, the better you're going to be able to protect yourself commercially. The next reason data matters is it's the only way we have to learn and improve as a business, as a system, other than as an individual. Most lessons learned on projects stay as lessons learned with the individual. The project manager learns about a certain type of paint and whether it works on a certain type of structure, or that a certain supplier's product isn't well suited to another supplier's product. Generally, those lessons stay embedded in the project manager and he takes them with it. Yes, he can apply them to projects going forward, but the business never captures this data. With data and records, as a business, as a system, we can learn and improve and basically stop repeating the same mistakes every single project. We can use things like estimating feedback loops, where after the job, we use our actual cost data to estimate the cost of the next project We look at the specific issues we had, where we had drops of productivity, where we had delays, and integrate these into our projects going forward using our lessons learned. And we can always use data to improve the performance of our ability to schedule. So many construction management functions rely on input from experienced individuals. The more data we can collect, the more lessons learned and insights we can capture, the more that the business will be able to prevent the mistakes happening on their future projects. Now, the final reason having good data is essential for a construction business, and this is only going to become bigger and bigger going forward, is as AI is integrated into more tools, the more data we have about our projects and our performance and our specific situations, the better we're going to be able to use these models. Our ability to use these AI models so heavily relies on the context we give them around the problem we're trying to get them to help us solve. The more data we have, the more specific insights we have, we can improve the context, the prompts, and get much better responses from these AI tools. Okay, to summarize, data is useful when it helps us see what's happening now, predict what's likely to happen next, back yourself up when challenged, improve future performance, and to get the most out of AI tools moving forward. The next thing I want to talk about, which I think is important to bring up and address, is why managing data on construction projects is unbelievably difficult, but not just managing it, but getting the most out of it. Unlike manufacturing, construction doesn't occur in a controlled, repeatable environment. Every project is different in distinct and important ways. The contract model might be different. The scope and responsibilities of the client and the contractor and the subcontractors will be slightly different. The location, the ground conditions, existing utilities, the weather, the product, and the suppliers will all be different project to project. This variability makes two things incredibly challenging: capturing the correct data consistently, the data that's actually going to help us improve our projects and business, and then using that data later in a meaningful way. I want to use a really specific example from two projects I worked on and then my future involvement in a 10 to 10. So before moving in to Construct IQ full time, I used to work on the construction of solar farms and around inverters. So what converts the DC electricity into AC electricity on solar farms, we always put in some sort of in-ground earth grid. I was working as part of the tender team, and someone when I was working with asked me, "Do you have good numbers on the productivity for installing these earth grids?" And I looked at my cost tracking records from two separate projects to try and give a meaningful answer to this question. Project one was a solar farm that used power electronics inverters. The earth grid was installed in summer in dry ground conditions, and it was a 120 millimeter squared earth cable with 4 terminations per inverter. Project 2 used SMA inverters. It was winter, it was muddy, and the design used a 70 millimeter squared earth cable, and there were also 4 terminations per inverter. On Project 1, we didn't have to track and report the individual earth terminations. We just tracked the number of earth grids a crew did per day. It was a rolled up number, including the excavation, laying the cable, terminating the fit off, and the backfill. On Project 2, we had a specific format we needed to report productivity to our client. So we tracked the number of individual earth terminations. So when I got asked this question from the estimating team, can you give us some numbers to help estimate future projects going forward? I looked at the two sets of data I had, and the numbers, the information, the format of the information was completely different. The tasks at face value seem relatively simple, but everything about them was completely different. I find this is an incredibly common theme when people talk about data on construction projects. Yes, you have data, but it's in a different format, it's captured at a different level of detail, and it reflects different design, site conditions, and other project specific information. So when it actually comes to being able to and wanting to use this data in the future, it's not just plug and play. You need to understand so much context and information around the data, and it almost becomes useless. So even that incredibly simple example of a task on a project and wanting to use the productivity rates from that task to estimate something going forward becomes an incredibly complex and challenging job. So let's dive into this in a bit more detail. Let's explore what specifically about construction makes these two things, collecting the right data and then being able to use it going forward, very challenging. So, number one is simply that every project is unique. No two projects are exactly the same. Even if you're building the same road, the same number of lanes, the same lights, the same everything, they're in different locations. There's different contract types, there's different delivery models, there'll be different weather, there'll be different project teams, there'll be a different design, there'll be a different client, which makes them almost incomparable because so many important contextual things are completely different. Manufacturing, on the other hand, it's the same process repeatedly on the same production line with the same highly controlled inputs. Reason number two is that information is scattered. The data, the meaningful data we need on our project is trapped in chats, emails, PDF, field notes, spreadsheets, photos, and the worst one, people's memory. Manufacturing, on the other hand, it uses centralized enterprise reporting processes. They have SCADA systems. It's structured, it's timestamped, it's categorized, and it's set up to be able to reuse. The next challenge is we get inconsistent data structures between projects. One site might track daily crew hours in a spreadsheet, another might write them down on a whiteboard. More mature industries like e commerce log every user action and financial traction in the exact same format across platforms. The next challenge is that tacit knowledge or knowledge gained through experience gets lost. There's no good ways to track and manage this data. Foremen, engineer, and project managers retain key experience on their heads, and yes, they can apply those lessons learned on future projects, but there's no way for the construction businesses to capture this knowledge. In more mature industries like the airline industry, they actually have standard operating procedures, process logs, and even automated sensors for capturing and retaining this critical tacit knowledge. The next reason data capture is challenging on construction project is that nuances often aren't captured. Important context around data we may track will often be missed, such as weather delays, design issues, site workarounds, and staging may never get recorded and associated with things like production rates or activity durations. Reason number six is the high pressure, low time problem. All construction projects are busy and stressful and often under resourced, and everyone prioritizes progress over documentation. In industries like manufacturing, they'll actually schedule downtime and QA processes as part of standard operations. They'll actually schedule as part of people's routine work, data capture, and build it into processes when construction is just all about speed and progress. The next reason is fragmented tooling. Construction projects use a lot of different tools for specific different tasks. We might do estimating in Excel, scheduling in P6, site notes in a WhatsApp chat, photos in our phones, and nothing ends up integrating. So all these, we miss a lot of context and nuance about the data we're collecting because it's recorded or stored in so many different platforms. The next one, which is a huge one I see on projects, is there's just no incentive for the project teams to track and record data. Project teams are always measured on the success of the project, whether the project makes money, whether the project finishes on time, whether when there's no safety and quality incentives. The team just has no incentive to actually set up, track, and record data in any sort of meaningful way. The next issue is that the construction sector has poor data governance. There's not standard rules of measuring, how to break down tasks, standard activity lists between projects, folder structures, field definitions, or frequency with which we record. It's just not good data structures that everybody follows. Another challenge with collecting data in the construction industry, and this is particularly a big difference to things like manufacturing and e commerce, which are automated software using robotics, is that construction is all about complex human workflows. There aren't sensors we can measure. We need to get people to manually record data and ask about tasks. So, again, manufacturing, we might have some robotics involved. There'll be sensors that track when something goes on the production line and when something comes off, and we'll get a time. We want to record how long it takes an electrician to terminate a cable. We need to ask the electrician. We need to get him to record the times. All of construction is complex human workflows, which is just inherently much harder to track properly. Similar to the poor incentive to record challenge is that projects inherently just have a one-off mindset. People want to finish the project, do the project well. They're treated as isolated jobs and they're not thought of as part of this bigger ecosystem as the construction business. And because all this data is so difficult to track, so difficult to use, is that we often don't even try to build feedback loops. We don't even try to set up systems where we use our cost tracking to improve our estimating or our lessons learned to improve our next project. It becomes something too challenging to do, so nobody even tries to set up proper systems for doing so. Problem with construction data isn't that it gets lost or that there's not enough of it, it's that the whole system is not designed for data reuse. I want to go into a little bit more detail on a point I made earlier, which is that data matters even more now, and our reliance on data is only going to get increasingly important. Artificial intelligence is coming, it's here, and it already has some incredibly powerful applications for the construction sector. But these AI tools are built on data and context, and the only way to get the most out of our AI systems is to properly manage and be able to use our data. First reason why this is so incredibly important is to be able to use these large language models like ChatGPT or Claude effectively, they need context. These models become more powerful and more applicable only when they're fed relevant information about the problems we're trying to solve them. If we give them generic, useless information, we'll get generic, useless answers. If we give them specific, actionable information about the specific problem we want them to help us solve or the task we want them to do, we'll get much better information. If we want Claude to produce a delay notice, we need to give the relevant supporting information in context. The limit of these tools is the context and information we can provide them. The next reason that data is increasingly more important is that these AI models thrive on patterns and recognizing patterns. If our data is structured, it allows AI to analyze trends, detect anomalies, and automate repetitive reasoning and processes. The next one, which I think is a critically important insight for the construction industry, is that unstructured free text data, which a lot of our data is has gone from not really being very useful, requiring a huge amount of manual processing and categorizing, to now being very accessible and very usable. AI can now make sense of the huge amount of text data that we used to ignore. For example, say across the years we collected thousands and thousands of defect logs. They might have had slightly different descriptions. One spoke about concrete cracking, one spoke about poor curing of the concrete, one spoke about the wrong mix design. In the past, this would have just lived like a huge text file or a huge set of rows in an Excel document. We can now give that to AI, get it to process it, get it to analyze it, tell us what the key defects are, what the key mistakes are we're making. All this unstructured free text data is now usable. The final reason why AI is making it more important for construction companies to manage their data is that contextual data or data we have about specific events, what's happened, site diaries, records, allow us to develop smart automations. When in the past we used things like software, filled out a site diary, and logged that site diary in a database, now we can take all the site diaries in our database and we can develop smart automations, things like generating progress reports, updating our cost tracking, all these tasks that used to require people manually going through and doing them. Using these large language models and AI tools, we can automate the entire task. Basically, the data divide is growing. Companies that can structure, track, and manage their data better are going to get better results from these tools. Construction has always relied on data. That data, most of the time, came from people's tacit knowledge and lived experiences, what they remember happening on a project, what they understood about the specific task for planning, monitoring, and tracking and monitoring records. Now, with AI, that data is becoming much more powerful and we're able to do many more things with it. Structured, consistent, and accessible data isn't just helpful anymore, it's a competitive advantage. It allows us to do new types of automations, improves decisions making, and lets AI generate new documents and new insights. Okay, so we understand why managing data on construction projects is hard, why data matters, and why it's going to increasingly matter even more in the future. Let's now talk about what good construction data management looks like. At the end of the day, it's all about understanding how we can use data to improve projects and business performance going forward. First thing that makes our data usable is if it's structured. What does structured data mean? It basically means we're using tables, codes, drop down menus instead of simple free text field. Say, for example, our construction site diary is a report that someone fills out every day and it ends up just being a huge set of free text data. It doesn't end up being that useful. We can't filter it, it's harder to analyze, and it's harder to compare. But if we have structured input with tables, codes, different cost codes, quantities that we can compare against project and dates, it becomes much more useful. The second thing that makes our data much more useful is if it's centralized. What does this mean? It means we're using one platform or one system to capture all our data. Think about it like Airtable, Notion, Procore for our entire businesses. All our projects are using the same tool to capture data. This prevents data being lost across different documents, WhatsApp chats, and email, and effectively just makes it much more easy to access and use. For example, keeping all our subcontractor RFIs and approvals in one shared project folder. The next thing, and this more or less goes without saying, but ensuring our data is relevant. What does this mean? It means capturing the information that actually matters. What information matters? It's things that's going to help us improve our project performance and business going forward. So these are things like productivities, causes of delays, whether we can use to justify claims, amount of rework, and what the cause of that rework is. This is information that we actually need to make better decisions, to prove contract claims, and these sorts of things. It's much more valuable than just recording a whole lot of noise that maybe we have a hope that one day it'll be useful. But at the end of the day, it's much better to track things that you know actually matter. And then the final thing to enhance our data and make it more useful is to be consistent across projects, across team members, that we're all using the same naming conventions, records, work breakdown structure, cost codes. If we standardize all these things, again, we're going to be able to compare data across team members, across projects, across activities. It's going to be much more useful. Okay, next let's talk about the key types of construction data. We're going to go through what the data is and what are some key data types that we should be tracking. Perfect world for a construction business, this is the type of data they would be tracking on all their projects again, in a structured, centralized, relevant, and consistent way. So, what type of data do we care about for construction companies? Well, first is cost and financial data. This is more than just your bucket. Good financial data breaks down how money flows, where it gets lost, and how it performs against the plan. In the perfect world, we'd have some sort of feedback loop where we're tracking our cost data on our project and we're using it to improve our estimates going forward. As I previously spoke about with that example of the inverter earth grids, it's a surprisingly challenging thing to do on construction projects. But what should we be tracking? The key data we should be tracking or capturing is our budgeted cost. So these are our breakdowns of the project budget by trade. These are our estimated cost, our forecast cost. So these are revised expected cost to complete as we're progressing through the project. Our actual costs, which is the actual amount of expenditure in invoices, payrolls, supply bills against each of these cost codes. Our committed costs, so our purchase orders, subcontractor agreements, these are costs we've committed on the project that we have not yet incurred. Our variation cost, what we're paying in variations to our subcontractors, what we're claiming in variations to our client. Then our productivity rates, which is where we compare cost and output per unit. We'll talk about this a bit more when we talk about scheduling data. And unit rates for different activities. So this might go above the cost code level where instead of looking at simply a rate for formwork or concrete placement, we're combining this into a unit rate for benchmarking the total cost of supplying and installing concrete structures, which is going to be useful for checking our estimates. Now, this type of data is all about the money and capturing the costs of doing the work. Okay, the next data format we've got is going to be our change and contractual data. This is all going to be about substantiating variations, getting variations approved, disputing variations with our subcontractors. It's all about avoiding he said, she said situations. So, for example, we've got variations requests, the reason, the amount, the status, whether it's approved or not, delay notices, when they were submitted, how many days, what activities they were linked to, what data do we get from both our schedule and our cost data can we use to substantiate these, client instructions, our subcontractor claims to us, and RFI logs. And the final type of data we've got is our daily site intelligence. So this is basically just tracking key metrics, notes, observations people are making on site. Can be used to help track labor, which will support our schedule and cost data, but also necessary for doing things like timesheets and paying people, material deliveries, what time they came in, who the supplier was, the quantity, which would be used to reconcile subcontractor invoices. So this is just basically logs of everything that's happening on site. Again, I want to wrap up this section by talking about something that I think is critically important but often overlooked. The biggest challenge you'll have when recording or tracking all this data isn't necessarily recording it, but it's using it later because the data doesn't speak to each other. We mentioned how our cost data, our schedule data, our quality data are all fundamentally related. How long the project takes to do impacts how much it costs. The amount of defects we have impacts how much it costs, how long the project takes. We need a way of integrating all of this data together to get the most out of it. And the only way we can do that is to have a unified framework where all our projects are tracking the same information in the same structure. This comes down to four key parts: having a unified task structure, so a unified way of tracking all the different tasks on the project, using the same metrics across projects to track these. So if we have a task for formwork, we track on all our projects, we use the same unit of measure, which is man hours per meter squared to form and strip, or whatever we choose to have. Tracking our external factors, so what influence the outcomes of the project, and tracking what decisions were made. So, the most important part of this is our tasks. Having a structured way across all our projects of categorizing different tasks. This matters because it gives us a common reference point to join our schedule, our cost, our quality assurance, and any other data. So, for example, if we have a task of formwork across all our projects, we're always going to know what it costs per meter squared to supply and install formwork on a project, how long it took, what quality issues we had. It's all tracked at the task level. It gives us the ability to make historical comparisons across projects or across tasks and projects, and it supports AI analysis. We could ask questions like, what usually goes wrong with this task, and integrate it into our checklist going forward. The way we do this is through the most powerful project management tool, which is the work breakdown structure, and a unified, consistent work breakdown structure that we use the exact same thing across all our projects. Once we've got a unified work breakdown structure, the next thing we need to have a unified metrics. We use the same metrics on all our projects. For each task, we collect performance data in the same way. This means we're tracking our costs, so our actual versus budgeted, our unit rates, our committed versus forecast costs. We're using the same metrics to calculate our schedule, our durations, our percentage complete, our planned versus finish date variance, our productivity, our crew hours per unit. We're using the same units across all our tasks. We always measure formwork in meters squared, formed and stripped. We always measure earthworks per meter cubed. Our quality, the way we're tracking and categorizing defects, and our safety. Again, this is going to allow for real-time control and project-related decisions. They're going to be much better, much easier for people to get across quickly because they're tracked the same way on every project. People can understand a project very quickly by looking at key metrics, but for people to develop that sort of intuition, you need the same metrics used across projects, calculated the same way. People can quickly spot the differences. And again, it's going to support forecasting, benchmarking, and using that information again. The next part of our unified framework for managing data on projects is tracking external factors. Now, again, in my experience, this isn't something that's often tracked in a reliable way, but not all delay costs, not all poor productivity is from incorrect estimates or poor planning. Many are due to external factors like weather, whether we've had a lot of rain, high wind, extreme heat, issues with site access and deliveries, delays to the design or extensive RFIs and rework, client actions such as delays from the client or instructions from the client, or permits and regulatory holdups. Tracking these external factors and how they impact these other core tasks and the metrics we're tracking is going to help us to understand our data better, enable better future risk assessments, And again, because we've got this power of understanding our data better with AI, because we've got access to all our free text data now, it's going to be able to, again, capture lessons learned from projects if we're tracking our external factors and giving this more concrete task and metrics. We're tracking better explanation power. The next type of data we should be tracking is schedule and progress data. So, scheduled data is all about the activities we're doing, how long they take, what resources we're allocating to them, how much work we're getting done per unit of time, per crew member. And we can combine this with our cost data. When we talk about schedule, progress, and cost data, we're really talking about the function of project controls. So, what type of data should we be tracking? For specific tasks, our planned versus actual duration, how long did we think it was going to take? How long did it actually take? Our progress percentage update, so tracking for every task in our project, where it's at, how much we need, how much work we have left. We can calculate our production tracking, so breaking tasks into meters squared per day, meter cubed per hour, day, whatever the relevant unit is. Delay logs, so where we're getting delayed, what the cause of that delay is, sources of variance, where we're wrong about our forecast, why we're wrong about our forecast, activity linkages, what are the order tasks need to be captured. Now, we don't often capture this sort of thing, but one of the biggest sources of delay in a project isn't necessarily anything happening that was unplanned, but it's just we didn't properly capture linkages. We missed linkages. This leads into the next point of capturing our look ahead data, how accurate we are with our short term forecasts. The next category of data we've got is our quality and safety data. So this is really capturing both compliance, risks, hazards, observations. So what type of data can we be tracking? Our inspection and test plans and how the tasks were completed, what inspections we had, what issues we had, non-conformance reports, categorizing them by type, what the cause was, the design specifications or mismatch, severity, the resolution, our defect logs, what are all the different types of defects we're having, what's the cause, who's responsible, rework data, SWIMS compliance, and recurring issues. All this data, again, should be tracked carefully, but this is going to end up being a lot more free text data that, with the power of large language models, we've actually now got some very useful applications for. Now, the final part of our unified framework for managing our data is actually tracking the decisions we made and why we chose to do certain things. Again, it's going to give the previous data we've spoken about better context, and it's going to help us actually assess whether we're making the right decisions, because the only way we can work out whether we're making the right decisions is to track them, assess whether we're making the right calls, and then improve these decisions going forward. Tracking things like, why did we change the crew size? Why did we approve that variation now instead of later? Or why did we push that pour back 3 days? This is all important context for us to help understand our data. It helps us to reconstruct logic, assess whether we've made the right decision, capture lessons learned. And again, AI tools and being able to understand that free text data in our construction data is going to be incredibly helpful with improving our decision making going forward. Okay, so we understand we need to track cost data, schedule data, quality and safety data, and our daily site intelligence, and that an integrated data framework is ultimately what is going to allow us to get the most out of our data. It's going to give us better forecasting, better root cause analysis. It's going to give us the ability to do cross project benchmarking, provide stronger claims and support our variations, and give us the ability to extract AI-driven insights. Okay, so we've spoken about construction data in a lot of detail and given you some frameworks for how to think about managing data on a project. I want to quickly wrap up by giving you a 5-step process you can use to approach managing data on a construction project. Okay, so here's a practical approach to managing data. Number one is start with a purpose. Before you capture anything, ask, what are you actually going to use this data for? You're going to use it for monitoring, controlling, generating AI insights, record keeping, for legal protection, or for future reporting and forecasting. The purpose you're using the data for will eventually shape how you choose to capture it and structure it. If it's for legal protection, you want timestamped photos and site instructions that are signed by your client. It's for forecasting, it will focus on consistent task level productivities. So once you've decided what you're going to eventually need the data for, the second step is to choose what to capture. So you can't track everything, so focus on the high leverage data points. Cost data, for productivity data, changes to scope, risk, and key constraints, and compliance or quality assurance data. Again, it's about asking yourself the question when you're specifically choosing what to capture is, will this data help us improve this project or the next one? If you can't succinctly answer that question, then it's probably not worth wasting the time and effort to capture the data. The next step is to decide how to capture it. This is the biggest challenge you see because if the data is difficult to capture, it involves people filling out long site diaries that take hours or doing lots of extra work. At the end of the day, it's probably not going to be captured properly. So you need to choose a way to capture it that is very easy to do, or perfectly, you could automate it. So it's not easy to capture, it won't get done. You should prioritize tools and workflows that fit into people's daily routines or they can do with the minimal amount of effort possible, such as forms and templates that automatically get sent to people that they can fill out on their phones, photos and voice notes, or automated sources such as a weather feed, GPS tracking, time card apps. You just have to think about this carefully of how people are actually going to capture the data. Because say for example, a foreman isn't going to bring their laptop with them to a concrete pour. So if you have a digital checklist, they need to be able to access it on their phone. So once you've worked out how you're going to capture the data in the easiest way possible, the next thing you need to do is choose where to store it. Again, you want a centralized database of all your project data. Your data needs to live somewhere that's searchable, where you can quickly find diary notes or variations through keywords or dates, structured with folders, tags, task IDs, and clean formatting that's easy to understand and for people to refer to, but also secure and accessible. Some popular options: 90% of construction companies will do all of this in Excel, and I've intentionally not put this on there, but Airtable, I've been loving and playing a lot with recently. I think is incredibly good at this. Notion and Procore, I know they have this functionality. I haven't played with it much. I know Procore is construction specific, but it's very expensive. And then if you want, you can use SharePoint and Excel documents. I find the cloud function on SharePoint almost always causes headaches with people overwriting files. And I have no idea why it's so bad, but every project I've worked on, we've had huge issues with people overwriting data in SharePoint. Some people working online, some people working offline, and it always causes headaches. The final thing is to design it for use later. I am probably overdoing this point because I spoke about it starting with the purpose and choosing what to capture, but don't just collect data, design it so it's useful when you need it. Again, if you're tracking cost data, why are you tracking cost data? You're using it to forecast and control your project, or do you want to track it so you can use it for your estimates going forward? You need to talk to the people who are actually going to be using the data. So if you're tracking it to use on future project estimates, talk to the estimators, what structure they wanted it. Again, it all comes down to designing how you're capturing the data so it's usable for later. Using drop-downs in codes instead of free text, timestamping, attachments, and authors if it's contractual data, linking the data to tasks and areas, having a standardized task list across projects, and ensuring naming conventions and templates are followed. Again, the question you should be asking, if I come back to this data in 6 months later, will it still make sense? At the end of the day, everybody in the construction industry loves to talk about how data is the future, but if you can't find a way to use it and you can't set up your systems to capture it properly, design it for the people who are actually going to use it, it's just going to end up being a big waste of time. So hopefully this video gave you some useful tips for how to manage your construction data more effectively. Everybody who's spent more than 2 minutes playing with ChatGPT or other large language models knows that artificial intelligence is a new, amazing form of technology, and like everybody, I'm guilty of overhyping it and probably overusing it. But to be a bit more realistic,
AI has some important risks for construction contractors and construction managers that we need to talk about. In this video, I'm going to lay out what these are and what you can do to mitigate them. The first one is data security and confidentiality. Using AI tools without understanding what's happening with your data almost certainly mean that you're breaking contract intellectual property clauses or your company's policies. The contracts your company signs as head contracts or as a subcontractor will almost certainly specify that you can't share intellectual property such as contracts, drawings, other sorts of documentation without prior written approval. Many free and cheap AI tools almost certainly state that they use the data you provide them to train their models. The reality is everybody wants to use AI, so if you're a construction contractor or a company, you should be setting up your own private large language model where your data is not used for these purposes. Number two is a big one, and I'm definitely guilty of it, is over-reliance and skill degradation. There was some incredibly disturbing, or at least I find incredibly disturbing studies that showed that workers who rely heavily on AI tools had a 40% reduction in critical thinking. Any sort of complex construction decision will rely on understanding the site conditions, the weather, the personalities, the specific challenges our project faces, and these are nuances AI misses. So if you're relying on an AI to tell you what to do, it's almost certainly not got all the context and information to be able to do it as effectively as you if you put the effort into making the correct decision. When we outsource thinking on complex problems, we get generic solutions, not the optimal solution. On top of this, a lot of junior staff and other team members may not develop that same critical thinking and experience as more experienced construction managers who develop their careers without these tools. The clearest mitigation I can see for this is to have a clear distinction or to train people on what to best use AI for and what to not use AI for. The third risk with AI tools is the commoditization of your competitive advantage. If everyone uses ChatGPT or other AI tools to prepare their proposals, then clients are always seeing the exact same thing and they don't become distinctive, you lose your competitive advantage. McKinsey actually found that companies that use AI tools in preparing tender submissions or submissions quoting for client works actually saw a 23% decrease in their win rates. What happens is your decades of experience, your unique competitive advantage gets flattened into a generic response. Clients can't differentiate between you and your competitors, and all they see is a generic response and a commoditized service. Again, I don't think the answer to this is not to use AI at all. I think the answer is to work out how to develop your own custom AI through context engineering and managing the context and tailoring your prompts and responses to getting the output that reflects your unique competitive advantage. The next challenge construction companies are going to face when adopting AI tools is a loss of innovation. This more or less relates to the previous point I made about AI impacting people's ability to think critically. At the end of the day, artificial intelligence are models that are trained on huge amounts of data. Yes, they can relate concepts together, but they can't come up with new ideas. In my experience in the industry, all the true innovation I've seen is unique problems solved with unique solutions, which goes fundamentally against this way of AI using huge amounts of data to train models and reproduce the most likely response. An interesting study by the Boston Consulting Group found that an analysis of 500 engineering design firms that relied heavily on the use of AI reduced the number of patent applications by 31% compared to their peers that weren't using AI tools. I thought that was a fascinating study and highlighted this exact problem, that if people are relying on AI to tell them what to do, they're not going to be coming up with new ways of doing things. The key takeaway here in the mitigation is that you should be using AI more or less for execution and automation, not for ideation, not for coming up with new ideas, but for executing on those ideas. Now, the final risk that I want to talk about is the fragmentation and shadow IT that is going to form in some of these construction companies if they aren't quick to adopt these AI tools. We can all agree they're unbelievably powerful and unbelievably useful for a broad range of construction management tasks, but
if companies don't allow workers to use them because of the challenges with data privacy or security or other concerns, the reality is people are going to start using them on their phones or find workaround solutions. 76% of construction workers admit using personal AI tools for work tasks without IT's approval. That is something I definitely saw at my old company. People using these tools outside of their company's permission causes these exact types of security concerns. So companies should get on the front foot and develop solutions to some of these challenges before employees start using them in the wrong way. The last one, again, which is a huge roadblock to AI adoption in the construction industry and something that I think is going to be increasingly spoken about, is the loss of accountability. If you use AI to prepare a safe work method statement, generate an estimate, or review a contract, and you're relying on the output of the AI, who is accountable if it's wrong? The AI said so won't hold up in court, and we're already seeing insurance companies beginning to exclude AI-related errors from professional liability insurance and coverage, which for construction companies where things can go very badly, very fast, that is an incredibly important thing to be aware of. Now, I think there's two ways to mitigate this. Number one, any AI-generated input needs to have some documented human review and approval. Someone has to click a button to say they approve it, or to only use AI in a certain specific way. Use it more for checking and verifying than for generating new content. For example, if you're producing a construction estimate, still do the estimate yourself, but you're using AI as an extra level of security and checking. You don't need to become a programmer, data scientist, or computer whiz to learn how to use AI. The gap is in technical knowledge, it's hands-on in experience, and in this video, I'm gonna give you 5 steps you can go through to master artificial intelligence as a construction manager. But first up, why should you care about learning AI? I think this goes more or less without saying, but AI and the ability to use AI tools is going to be an incredibly valuable skill in almost any industry. McKinsey predicts that 70% of companies will require AI literacy for management roles by 2027. Some studies are already showing that construction managers with AI literacy and skills earn up to 23% more than their peers. And to me, the use cases are obvious, you just need your imagination with how to apply it. For example, the average construction manager spends 35% of their time on repetitive tools. That was based on one study I found. I was shocked that it was only 35%. There's so many simple, boring tasks that if you learn how to use these tools, you can automate and you can get 5 to 10 times more work done. But not only that, it changes your job. Instead of focusing on the boring repetitive stuff, spending your time taking site diaries and putting them into a cost tracking spreadsheet, you can automate that stuff and you can focus on doing the work that actually moves the project forward. The creative problem solving, scheduling, planning, managing risk that we all love about our jobs. The learning curve is currently the smallest it will ever be. The tools are only going to get more powerful and more complex. Everybody I see in the construction industry is talking about AI, but nobody knows how to use it. Being early means you get to shape how our industry adopts the use of these AI tools and how it changes the future of construction. At the end of the day, it's not about being tech savvy, it's about staying relevant. So the 5 phases of adopting AI and becoming AI literate for construction managers. Phase 1 is to start using it every single day. I would recommend signing up for Claude rather than ChatGPT because it works much better. I find it much more capable. I prefer the way it writes, and it also has this feature called MCP where you can link it to your project directory, your files, and you can train it on your own data and speak to your data. And simply start working with real world problems you face every day. For example, say you need to write an RFI about concrete strength. You start with a simple prompt, write an RFI about concrete strength. You get a useless generic response. Instead of giving up there, what you need to do is you need to ask yourself, why did the AI give me a bad response? It didn't have enough context. So then you provide it a bit more context. You say, write an RFI for a commercial project where 28-day concrete strength showed 32 MPa instead of 40 MPa. The results, better, but still generic. So then the third attempt, you give it more context, a clearer prompt,
In this way, within 20 minutes, you get a usable RFI. At this stage, it was probably almost slower than doing it yourself, but the point is you're learning how to use it. That's why phase 2, after daily use, is to master the feedback loop. Through experimentation, you'll find more and more useful ways to use it. You'll get better at prompting the responses, what context to give, how to iterate on it. You'll be able to generate output, identify what's wrong, understand why it's failed or given you a bad response, adjust your approach, find ways to check and verify the answers. It's all about starting this feedback loop of how to work it, how to use these tools to get better and better outputs. The third phase of this, using it daily, iterating on the output, getting better and better at how to prompt it, is to begin to build what's referred to as your prompt intuition, which is basically an understanding of what these models are good at and what these models aren't good at. What does it perform well at? What are you getting the most out of it? What does it not perform well at? What is it better to do yourself? My guess at this point, where you're going to come up with a roadblock is the big insight you're going to have is that the content AI generates is powerful. It can probably do most things that you would want to do. The problem is you're limited with this text in, text out interface, and you always need to find ways to provide it more and more context. So that's why the fourth phase, so once you've started using these tools every day, you're getting better and better at using them, you understand what specific situations to apply it in, you need to start trying to build AI agents. So these is where you integrate artificial intelligence into your tools. This is how we get AI to do useful work for us. For example, we could use a tool like Airtable to build an automated site diary and reporting system. When you're using AI agents and building AI into workflows, start very small, very specific. Choose one very simple task to automate and slowly make more and more complex tasks. And then finally, you'll come to phase 5 of learning AI, which is where I'm up to. You need to choose a project to build, something complicated, something messy, something where you might have to build more complex automations, learn to use new software. This is where you find some more complicated task and you set yourself the goal of building something that fully automates it. Maybe you want to build an agent that creates your 3-week look ahead based off a series of prompts. Maybe you want to replace Primavera with a simple Claude artifact that creates Gantt charts, or maybe you want to try and automate your cost reporting. Only through some sort of project like this are you really going to learn the power of both using AI to build these systems and also the power of AI of itself. To wrap up, here's some principles I would apply when trying to learn how to use AI. Number 1 is always focus spending 80% of your time on reviewing the output you've been given rather than just blindly prompting it and taking the output. Always make that the goal where you're critically reviewing the output. Next principle is that iteration is where you learn. By prompting, getting bad results, prompting again, working out what prompts work, that is actually where the learning happens. It's not finding a perfect prompt that someone else has given you. It's going through the process of working out how you build that perfect prompt yourself. The third one is you need to understand that context is critical. The limitations of these models, at least in my experience, isn't their ability to reason or the intelligence of the model. It's how difficult it is to give them enough context around the task you want. To always focus on this concept of context and what information it needs to perform the task correctly. The last one is just start where you're comfortable. Start prompting it every day, using ChatGPT where you can, and slowly building more and more complex tools. At the end of the day, learning AI isn't about memorizing a bunch of prompts. It's about developing judgment through experimentation.